action tonight, just because it's the laptop's like over here. It's just barely out of reach, and then the drink's over here, and then I have to like move to like switch between the mixer. So just simplify one other thing. So let's do that if that's okay with you guys. Yeah. So trying this out. Needed a bit of a break today, so thought we'd give it a try on the couch. What else was I gonna mention? Forgot.
All right. All right. What else do I need to do? I think I'm all ready to go.
And everything got reset.
Oh yeah, I need to get stuff over to the other desk.
The stream and the last stream were at 720p, 60 FPS.
Metro's talking. Does this need updating?
So.
No. Good. Fusion actually works.
4K camera does this absolutely
Talking.
good.
He's gonna talk right into a copyrighted song, right? Excuse me. I'm a little rough today. Hold on, I'm gonna mute while I get stuff. I had the mic on for 2 seconds and it's already caught in both the floor fan and my office chair. I don't know how that happens. All right, activate earn the subs. There we go. Everybody's ready to go. Might have to grab another Red Bull to make it through the day today. I am tired. Tired and porky today. It's hot in here too. it's hot in here. I'm suffering. I've got a fan on me right now from behind. I might need to move it again in order to get myself properly cooled in this space. I think the AC is on, but it's, man, I don't know. It's not even like hot out today. What's the weather today? It was like 75 degrees, but it's northeastern humidity, man. I'll tell you something. It'll kill you. But also fuck up your hair. I gotta look good on camera, you know?
What's up, Zero Cool? Good to see you. Same old house.
Stop talking. Talk. It's like he's not even trying to be my background music. I don't know if we're gonna have much to do with thermals today because I'm not really gonna be testing the motor. We do need to get back to the motor testing though. That is a whole bag of worms that I got sitting right here. That's a whole bag of worms. We got the motor test set up here that's been through the ringer a couple times. probably need to rebuild this so that I can test. Because we put it together and we tested these MOSFETs and they work perfectly with the motor. But with any of the stronger motors, like the Plasma Dash, they immediately, like some kind of like a cut happens with the power line. Temperature will be back on the 90s on the weekend. Well, I was enjoying getting a little bit of air, but I guess a little bit of fresh air in the house. Like we had windows open for a little bit. I got root beer. It's like the Federation. Diet root beer. But yeah, like we had the windows open during the weekend. Like the house got to air out a little bit. No, I don't.
Also,
No.
I'm losing my voice a little bit, I feel like. But and Juno Denay, thanks for the tier 1 sub to Michelle Hand.
No. My alt account, Obama. No, I'm just stealing content from Metronome. That's what I steal. Oh, there's another beard hair. I always do that. I like adjust the whiskers a little bit, and then I end up plucking a beard hair inadvertently. So, a couple things. I do want to get back to doing computer stuff, computer building, computer case building, because we still have the Stream PC to work on. That Stream PC has been in the way for quite a while. Oh, there it is. My food is settling. Okay, all right, camera. Sometimes it is super duper hard to move the little camera mount. Other times, super easy. Yeah, so that carcass right there, that rack case that's completely empty, I want to take lessons learned from the other computer case project. So I want to frame that like I did the other computer case with orange translucent 3D print material, but put that reservoir up front and then try to fit water cooling apparatus inside of it. I tried to have the radiators external. It turns out, believe it or not, the rack case is utilizing about 100% of that opening, and so there's no way for me to get that in there if I've got an external radiator on it, unfortunately. So I'm gonna have to move the radiators internally, somehow fit the Stream Archive hard drive in there, and then I think I'll be Gucci. I think we'll be good to go. But I'm not gonna water cool the graphics card until I can find a solution for the 1080 FTW that I have in the other computer. I realized that the case that I built, the one that we just refreshed, the one that I'm gonna update with the 5950X, the case that's now in my desk, that is 300 millimeters deep. And see, why is he, stop talking. Talk. That case is 300 millimeters deep, and the 6900 XT is 340 millimeters. At least the XFX is 340 millimeters. So that won't fit in my case. It's not gonna fit in my case. I don't know what to do about that, because I don't want to reinvent the case for the graphics card. Theoretically, it should be able to function under the power supply. We did some pretty intense calculations on that to try to figure out exactly how much my power supply could supply versus how much that level of technology would take up, a 5950X and a 6900 XT. I don't know if I'm gonna wait until next generation of graphics cards. I think I might have to. point. You can tell by all the crisscrossing going on right here, but ugh. This thing was a nightmare. Also because the area that the A-arms mount is offset. So there's a little offset here. One of them is the center for all the stuff that involves the A-arms, and the other is the center for the rest of the drawing. I'm gonna burp. Yeah. I don't do a hell of a lot of mechanical reverse engineering, but I ended up doing it with this. Pretty wild stuff. And then from there, I've got 75 other sketches. I had to do another sketch just to make sure that that one sketch wasn't too cluttered. This is the stuff on the top. Ridiculous. I'm wondering if they designed this by taking a solid and then plopping the transmission in and then hollowing it from there. By the way, it's not perfect. Like, there's something weird going on right here. That should not be there. I don't know what to do about that. I could correct that later, but since I'm not screwing around with transmissions, I don't need to care. I don't need to care. I'm not screwing around with the differential in here. As much as I want to invent a 3D printable torque sensing torsen differential, it's not gonna happen. This stuff is too small for the 3D printer, to be honest. Too small for the 3D printer. Unless I want to fuck around with a smaller nozzle. I don't want to fuck around with a smaller nozzle. No, I don't have an SLA printer. I don't feel like having that kind of mess around here. I'm not gonna spend, you know, hundreds of dollars just to have a epoxy mess on my hands. But bump. Man, it's nice to have the dedicated streaming computer again. Where are my lines? There we go. Yeah, I just don't want to mess with all the like UV bath and all that other stuff that SLA printing entails. It's just too much. Coughing again. I'm a wreck today. I didn't sleep last night. Or rather, I slept in my chair. Bad idea. Bad idea. I don't know what it is about my self-sabotaging on days before streams. I'm gonna take Wednesday to kind of like be a good boy and actually get some sleep. And then on Thursday I'll be spry once again. Maybe we'll do some maybe some computer stuff. People like computer stuff. And neither my daughter had a sleepover and there was giggling all night. Yeah. Get the screechy little girl screams. You can hear those in the neighborhood sometimes. Why is it the kids always have to scream bloody fucking murder all the time? Like, do I call the cops? Is it a serial killer? Nah, they're probably just playing. For these gears, I actually used a Fusion 360 tool that came with the thing. So under the tools menu, I was able to use an add-in, scripts and add-ins, and then all the way down here, there's spur gear. So if I run that, it asks me all of this information on gears. And so I didn't know about gears for a little while. I had to look some stuff up, but it turns out the number of teeth and the module and the outer radius of the gear are a very simple equation. Outer radius times, I think, module is equal to the number of teeth. So I was able to figure out the module for these gears, which turned out to be a very weird number. It was like 0.5 something something something, or like 0.05 something 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 something. But it worked out. I was able to make the two gears, and the way that they placed, they actually do mesh with one another, just default, in their default placement. I have to spelunk all of the parts that I've got in this drawing. Ugh, look at all these things. Where is that? What did I call it? Beep boop beep bop 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 bop. There we go. So that's pretty cool. Those mesh pretty well. I took this to be the default center position because it's 12 millimeters from this hole, but we need to redesign this because that doesn't work. And we'll get into why in just a minute here. There's a cascade of unfortunate failures of measurement on my part. But the song is too much of a banger. By the way, if you're interested in this music, think it's cool, you owe Metronomic Live money. I haven't paid him $1. But I don't know. Exposure, people die of exposure, so here's Metronomic Live. I'm shamelessly holding him up in front of the copyright robots so that he gets pinged first instead of me. It is an awful thing to do to somebody, but that means we get intro music. Oh, he walked away. Oh, he's gone forever. Oh well. Now, Metro's cool people. We see him in chat every now and then. He's cool with me doing this, which is nice. He could say no, and I would find other means by which to have some kind of an intro that moves along without me. All right, no, I know that's copyright. That's no bueno. I'm just not even gonna let that. I can't let that fly. This might still be the same song. Nope. Sorry, even samples aren't safe anymore. They'll ping you for. Stretched today. That's what it is. I feel like I haven't stretched at all, even though I'm fully awake, and yes, I have stretched. It's just for some reason I'm just not. Ugh. It's kind of bleh. All right, yeah, we might as well just get started. Let's just get started. I'm already late. Let's fade out Metronomic for real this time. Goodbye. Yeah, but you can't guarantee that you're talking over a song will actually confuse the copyright robots. It's really annoying like that. What's funny is actually making the stream start soon smaller keeps people from commenting on it constantly. Anyway, look at what I got. I didn't have this as of the end of last stream. This is a comprehensive 3D model of the wltoys 989 kit with my own modifications. So this is stuff that I had been working on for the wltoys 989, including some of the metal replacement parts and their precise dimensions. I've been working on this model for quite some time. And why did I do this? I don't know, because I'm a little bit autistic. I don't know. I really wanted to model out exactly where everything was located and do my best to reverse engineer a lot of this stuff. These parts have been a little while in the making, and you can see all the huge number of these that I've put together. I just wanted to get a more comprehensive model of the kit. Now, I didn't do ball joints yet. That's something that I'd like to do, and we can work on that, or maybe I'll just work on that on my own. Springs are also something that I have not modeled yet. I wasn't able to source a good model for this piece of kit. I also am including the carbon fiber furniture that I bought, all the aftermarket parts. So the only stuff that really remains like normal in this kit, hey, Prince Palindrome, thank you for following. The only things that are like original equipment are the spur gears and the drive shaft. And then the battery holders. And I actually built a model for only one side of the battery holder, but it was interesting to get into a lot of the numbers that they chose for these different pieces of kit. Like this plastic, they basically drew a box around the battery size, extruded it out into walls, did a chamfer on the side of the walls, then softened everything up with did a fillet on the side of the walls, and then softened it up all with chamfers. You can kind of see like where the chamfers are on the real thing and on this model. Hold on, I think my desk isn't on full brightness. Ugh, I don't need this heat that the desk is going to produce today. Yeah, there was a lot of very interesting stuff. There was also a lot of stuff that was absolutely annoying, absolutely the most frustrating thing in the world. We got to correct some stuff on this too. There are some dimensions that have had cascading failure results in terms of my ability to design things on this model. But what I had to do is get into the head of the people designing it. How do you make a part that looks like this? Well, you start with this circle here and these two mounting points. And so you've got a distance there, you've got radii, you've got 1 millimeter wide posts, and then you have basically a 3 millimeter by 3 millimeter box, and then a radius here in order to just basically soften that up so that it's not like a direct straight over kind of piece. It is weird stuff. I had to put this chamfer, or sorry, this chamfer had to go in before I made this hole. Otherwise there wouldn't be material there, because that gets so thin right there. And that's how it is on the real thing. My God, it was just a lot of stuff like that. Just figuring out how to put these things together. God, fucked if I know how these people machine a part like this. How do they machine that? Like, what do? Do you set up like a CNC factory and it just pukes out 10,000 of these? And then you put them all in storage? Like, I can just go online and I can just buy a part like this, that's this complicated. CNC Music Factory. What did CNC whatever Music Factory, which one did they do? That was that wasn't Good Vibrations, was it? Good vibration. Things that make you go, hmm. Yeah, so anyway, there's a lot of weird stuff that I went through in order to create a lot of these things. The transmission, or sorry, I keep calling it like transmission or like gear housing, or it's basically a differential housing. There's a front and a rear differential housing, and they're the exact same part. But there are mounts on them that are in weird locations. I did some stuff out of order on this part versus on the real thing, so I wasn't able to make this rounded sort of thing on the back end. There's a slightly different shape to the real one than what I created, but I got it as accurate as I would need in order to create 3D printed parts for this kit, because what I'm doing is I am converting it over to the smaller and potentially more powerful. Good Vibrations was Marky Mark. Ah, that's right, and I'm not proud that I know that. I'm just gonna, Rum Monkeys is the one who said that. I'm just gonna make sure that that credit gets passed out where it's due. So yeah, reverse engineering all of the stuff so that I could make a 3D printed adjustable motor mount for a 130 sized, because the original kit had a 180 sized motor and then has 2 screw holes in it, but the 130 doesn't have any screw holes in it. And instead of clipping to the main body of the motor, which gets hot, I decided that I would have 2 adjustable mounts that I would attempt at 3D printing. In order to do that, I needed to make a bunch of other changes, including a different servo, because the wltoys kit comes with this godforsaken fucking servo. I don't know what it is about this thing. This is like, I can't find it anywhere. You can find these listed as wltoys. Let's see, is the microscope looking all right? I didn't calibrate the microscope, but I think that's all right. So you can find these only as, here, let's turn that off. Let's turn the thermals off for now. What was that? No. Turn that. There we go. So, yeah, this is the wltoys W989 kit with a servo saver. I would barely call this a servo saver, by the way, because this thing requires so much force in order for it to work that I don't even know if it's worth it at all. I'm looking at buying another servo saver for it, which means I have to change the modeling around. But anyway, this servo is like impossible to find. Now, I was able to find replacements for it. I found this is actually a pretty good replacement for it, but it is like a cursed servo size. It's not quite the more common there's more common servos that are both larger and smaller than it. And what I ended up doing is looking around at GrabCAD to see what kind of models existed on GrabCAD in order to replace that servo. And I found, what is it, the KST X60N. N for no ears or whatever, no mounting tabs. So KST makes all these really weird looking servos, and they're very high quality. They're $40. $40 servo. I'm not happy about that cost. That's twice as expensive as the 130 sized motor. See, the 130 sized motors, you can find a variety of them, and they're pretty powerful, as opposed to the 180 motors, which are way more powerful, but I don't feel like I need that amount of power in this model. So I'm using the 130 size motor, and in order to do that, I need to make a special motor mount, and in order to help with that, I would like to model where the servo goes and redesign it a little bit, and so there it is. Would you ever DIY a motor? I've got a couple, I mean, yeah, I might. I might. Don't tempt me. Don't tempt me. I was gonna build a motor out of a motorcycle generator, and I had all the winding stuff and everything ready to go. I just never went forward with it. I had really thick enameled motor wire that I was gonna put together, use a bunch of rare earth magnets and make like a brake plate motor kind of thing. Yeah, the wheel dynamo. Yeah, exactly. I was gonna try to make like a hub motor, but I never got around to it. But yeah, winding your own motor is fun. One of the tricks that you do is you take like a syringe, like a normal syringe, and you pull the plunger out, and then you put a larger tip on it, one of the blunted tips. You can just buy them off of Amazon. You put a blunted tip on the front of the lure lock, and then you put your winding through the syringe, so you can hold your syringe and then wind it very, very carefully with the end of the syringe, the cut end of the metal syringe, and then you can not very, but you can accurately and carefully do the windings so that they're good. I like doing that. I think it would be fun to make my own motor, but I don't know. Hermit's so hard. How you doing? So yeah, this is the design that I initially created, and we got to make a lot of corrections to it. So this is the what is it? The KST motor, and I was concerned about whether or not this thing would have enough force to actually move this thing back and forth. I lifted the servo a little bit off of the base plate so that it would be at about the same height as the original servo, as this guy. It might be a little lower than that, but I've fully gotten this working, actually. I'm gonna start winding my own guitar pickups. Yeah, the syringe thing is like a great way to do it. That sounds awesome though. Man, where'd you get why does your guitar sound so good? Oh, it's the pickups. Oh, where'd you get the pickups? Made them. Where'd you get the parts? Made them. Anyway, so this servo I've gotten to mount. Now, we're talking about 3D prints on this model that are a little bit small for my liking. By the way, I had to get the version of this motor that had the oh, look at that. I had to get the version of this servo that has the tabs on it. So I had to make a little alteration to my 3D model. Best hack, wind your pickup bobbin with your Nana's sewing machine? How does that work? That's a cool trick. Yeah, so I had to get the version with the tabs. I have a version without the tabs on its way. This is just the fastest shipping that I could get so that I could actually go forward with the design. But it's looking pretty good, and I was able to get the servo mounted in, and it's just about in the same position, right? So I set that up. The reason I got super duper shipping was I had to, go forward with the design. You might be asking yourself, well, why are you going through all this trouble? Well, because what I'd like to do is take the circuit board that I created that holds both the radio and the gyro, and I want to make this circuit board smaller. Now that I've got the confidence in these transistors here to do the DC switching, and I made a mistake on this, right? I got one of them working. I almost have the confidence. We got to figure out how to filter noise in this thing. But once I get there, barring any horrible, terrible wiring mistakes that I might make throughout. Once I'm able to get all this stuff onto a more compact circuit board, I would like to put it right on top of this servo. And I want to fit everything under this bar here. So I want the entire electronics to be in this little space right here. None of this makes sense to me, and I love it. It's a tiny RC car, and I want to make it go vroom vroom. That's basically what I've been doing. That's what I've been working on. This isn't, by the way, this is like literally just like a vanity project for me. It's not like I'm making any money off of this. I mean, I can't with the, hey, PhatAnon! RC car goes burr. Subbing at tier 3. Bump, bump, bump. I need like fanfare or like a sound to play when this thing goes. I need to make noises like sparks and stuff that go off. Mo Pork Ham Crusher. I love that Twitch name. Mo Pork Ham Crusher. Thank you for following. Well, let's put PhatAnon up on the board before we continue here. For those of you that don't know, because like 1 in every 3 chats today has been from like a totally new viewer, this is a board on my wall. It is powered by a Raspberry Pi. It is a Blue Laser XY etcher. What takes names from the Twitch API and places them on a board. That's the simple part of it. The complex part of it is Python running multiple different threads and creating virtual images of the board in order to place names. And of course, all the work that I did turning the Avener font into a single line font. Turns out that one day of sketching, actually that took me a couple days to be honest. Taking Avener and all of its vector coordinates and turning it into a single line movement was difficult to do, because like, where do you stop? You can't just do the center of everything, because that doesn't look right. Some letters are going to be off from others. So yeah, but yeah, this is the board. This is what I have in exchange for, you know, instead of me wibbling my ass in front of the camera with a whiteboard marker, I have 4 planks of maple, 1 inch thick, no, ½ inch thick. It's about an inch. No, it's about half, 3/4 of an inch. 3/4 of an inch of maple that I've glued together on my wall. We will work on Burn the Subs 3. We're gonna pull that stuff back out, and I need to get to some of that stuff that I've been working on. We need to do that XY test and start moving stuff around on that, just to get an idea of what we're working with. But yeah. Belky Studios, thank you for following. I'll like move that. We'll move that like there. There we go. It's weird how the dirty names stick together. Yeah, PhatAnon went in kind of a clean area. If you gift a subscription to this channel, the giftee goes up on the board. So that's what we're working with here. People found Twitch names or made. But the confusing thing is the Twitch names that were, you know, the one person that was influencing everything, making the name underscore, it's like something underscore sex joke style names. People were looking at those accounts and they're like months old. So I don't know. I don't think that person had a shit ton of alts that they were suddenly gifting subs to in order to make jokes on the board. I think maybe it was just their method of searching for comedy names. Tier 3 gets me on the board. Any tier gets any subscription, and if you gift a subscription to somebody else, the somebody else goes on the board. That's how it works around here. It's exchange. Any exchange turns into actual names on the board. So after actually creating the board, I also created this thing right here, which is a comedy fart noise maker. What was sent to me by 3mares. We dissected it and we plugged it into a crap, I forget what the name of the chip is suddenly. My head hurts. Yeah, anyway, we plugged it into a little Wi-Fi microcontroller and got that to go onto the Twitch API. And then the Twitch API allows people to spend money on rendering a physical random fart of 9 random farts. they can actually render a fart into the real world. ESP, yeah, it wasn't a 32, it's an 8266. But yeah, we gotta work on moving this computer into the rack case. I think that's what we'll do on Thursday. Thursday, I'll take the rack case out and we'll do a little bit of work on that. Yeah, the speaker is a Harman Kardon speaker because I happen to have one. I stabbed the other speaker I had with a screwdriver on camera. I don't think that was worth the joke. But, Mo Pork Ham Crusher. How'd one go about learning what you know about hardware? I'm fairly decent at coding. Doing. You know, I've been doing for a long time. That's where all of the, that's where all the skillfulness comes from. That's where all the confidence comes from. But everybody, like, hardware is big nowadays, right? It didn't used to be. You know, I used to have like a couple niche magazines. This is back in the days of magazines. This is back when websites were like just HTML text and stuff. But like nobody, the maker scene wasn't as big, right? Or it was, and we just didn't know how to contact one another. Internet came along. Everybody started getting into niche hobbies, and hardware is now like fucking amazing, right? You can go to like SparkFun and look up tutorials on how to do basically everything. And you know, getting a level of confidence with hardware, for me at least, it's just by doing stuff. You know, you look at something that you want to actually improve in your life, and you sort of break down that problem into parts, little bite-sized chunks, and then you go about it chunk by chunk, and just make sure. I mean, the most important thing that you can do is follow through and actually complete what your goal is to complete. I don't mean the entire project. Maybe the journey is, you know, going to change the end result. I mean those bite-sized chunks. You want to take it all the way to fruition, and that's where it really gets tough. When you start and you're buying stuff and you go, this is going to solve all my problems, and you click order on like 500 different parts that you're never going to use, that's the fun part. And then all the stuff comes and you go, oh no, I have to use it. And so that's what we're doing today, is we're getting to that point where I've done the fun part of the project. Look, there's the fun part of the project. I have designed parts in a 3D model that I've reverse engineered from a bunch of parts, and then I put the parts with the parts, and I use the parts to destroy the parts. And now all of my shit sucks because I made a mistake. And that's where we are. You see that gap right there? Look at that gap, that thigh gap that we've got between the spur gear, the main spur drive gear, and the part that I designed. You see that right there? That ain't happen. There's your problem. I'm gonna sneeze. No, wait, no, I'm not. I almost did. By the way, I'm using the Plasma Dash as a size guide. I probably should grab the Light Dash out of the other 3D printed one. But anyway, yeah, there's problems. And you know what the problem is? I bet you don't. Well, I did actually talk about the problem in my Discord, so, yeah. The problem is reverse engineering parts. Reverse engineered parts is the problem that I've run into here. So all of my... No, acetone sculpting. No. So getting into the head of whoever's designing the thing, right? So this is one of my first-ish forays into hardcore mechanical reverse engineering. So what I've been doing is figuring out how these parts were designed. And I started with the carbon fiber parts. I started with the carbon fiber because I had an extra one lying around. Remember, this all started as Mario Kart. I was going to take the Mario Kart augmented reality thing. This thing right here. This was Mario Kart, the little camera and everything. And try to get it running on a 1/28 chassis, because that's what it originally was. And it turns out the motor is weak as shit. The motor was not able to even turn the stock wltoys 989 kit, because the wltoys 989 kit is so badly made. This one's the 969 giggity because this one has locked axles. And so I bought the 989 and the 969. One was all-wheel drive, 2 differentials, and the other was locked axle drift car. They're both very badly made. It requires a lot of force in order to get the drivetrain to move at all, which is probably why the Mario Kart is rear-wheel drive only and has a fairly loose drivetrain. It's pretty good. I mean, it's like a couple gears and then there's no differential. It's just a solid rear axle, and it doesn't have to go fast. Neither do these, but it turns out buying new differentials, pulling stuff apart, replacing a lot of the parts is kind of necessary with that kit. But I'm running a 1-cell battery on this too, so I'm actually like kind of running at a disadvantage as much as possible on this kit. But anyway, I've been wanting to kind of like redo this and get one of these 130 motors mounted in there. But I discovered, and this is the thing we're going to try to correct today, I discovered that it turns out you cannot trust reverse engineered parts. So this is the original wltoys top bar thing. I mean, this is providing stability to basically the whole model, and you know, if you crash I'm hoping that this thing will be towards the top. It'll be one of the more strong pieces of the whole thing. But anyway, this I was able to buy for like 20 bucks, a new carbon fiber base. I came with the new carbon fiber crossbeam that has more holes in it, more adjustment. You can adjust the front and the back. However, oh yeah, and you can put a switch on it too. That's pretty cool. But matching these two up, which I didn't do until I've already had comprehensive 3D models of everything, matching these up, they don't quite match up. Here, check it out. So if I line up this hole right here, I'll focus. All my cameras are out of focus right now. I line up this hole right here. The overall dimensions line up. The holes that exist there exist on this one. I'll line that up a little better. That lines up. That looks great. It looks like they added some holes. That's fine. But over here, if that base is lined up, this hole's fine. These are not. Look at that. All this is all this is doing is making me want to build my own RC car from pre-made parts. Yeah, I wish the wltoys one was like a you assemble it kit, because it's not all that complicated, but it would have been fun to build. It came pre-assembled, which is, you know, buying all of these random ass parts in order to create my own 3D model and then 3D printing my. This is really where it's becoming really fun for me. But like, all right, so look at that. They're off. They're off by like, I don't know, almost a half a millimeter. Almost a half a millimeter. This shit right here. This is starting to, you know. All right. Testament to the accuracy of the model that I created. Yeah, I mean, what did Flatulent Gonad was telling me, like, you could take carbon fiber powder, which I think it's all like mixed up in my vacuum right now. You can take carbon fiber powder and epoxy or super glue and fill in the holes if you need to. That makes a pretty good substitute. And then maybe re-drill them. I was thinking of just getting a file and just stretching the holes. Yeah, hold on, I don't cough. I had leftover Chinese food and it was kind of dry. Ugh. I got like rice noodle in the back of my fucking throat. Yeah, this is a lot of fun. I'm having a good time doing all this stuff. I do want to, you know, get to the circuit board design and everything so that I can make the kit and actually drive the car around. But for me, building this stuff is the more fun part. The problem is this is going to become the only topic on my stream. So I got to be careful. I have to, because I have been working on this thing all fucking weekend without many breaks. Maybe this is my weight loss program, is instead of eating, I can work on this tiny little RC car. But the problem is, every time I work on it, you know, I spent $40 fucking on a servo. One servo? Come on. I can't keep getting away with this. Anyway, so those holes are in the wrong place. I'm thinking of taking a file. I don't know if I have microfiles that fit 2 millimeter. Re-drilling them, I think, might be really, really difficult to do. And I feel like that's way too much work. So I think just filing them in order to get them to the right dimension. But like all of my... Here's what happened. I took a flatbed scanner and I scanned the carbon fiber pan because I wanted to get all of those dimensions in there. And then I scanned this piece as well. And so I created the carbon fiber pan with all of the holes in it based on a flatbed scan. And I reverse engineered the sizes and the structures and the locations, but they're not amazingly accurate because I don't know what this was based on. I don't know where the dimensions are coming from. So a lot of the stuff was kind of up in the air, and I tried to make everything even numbers. Then I reverse engineered the crankcase. And again, I also reverse engineered this one based on a center point. All those holes are mirrored of one another. Then I designed the crankcase as accurately as I could. And as I went, I got better and better at reverse engineering these parts in order to figure out exactly what the dimensions of the holes were, where they were located. I discovered that actually you may think, and I'll allow you to do that, you may think that this hole right here, much like this hole right here, goes through the entire differential casing all the way to the bottom where it'll line up with that hole down there. You would think wrong though. These are about 0.5 millimeter wider than the actual holes that are there. As if, just to fuck with you, these are 0.5 millimeter in. They're 18 and a half from this center to this center, whereas these are 19 from center to center. It is just a nightmare. So they did this by having this hole go through partially and then another hole go through the other way. It's like torture. It's ridiculous. Absolutely ridiculous. So these are the things that I learned along the way, and I had to keep adjusting and adjusting and adjusting. So it turns out that the holes in the bottom plate, I based on the location of this and the center of this. So I've got these mirrored with one another, and those are actually, I think, on an offset square that I put near the center. So I mirrored these to this side with a center, but it's offset by a little bit. And then I discovered that this thing is moved, which means the crankcase or whatever moves, which means the bottom holes, do you use PETG or ABS? PETG. Oh wait, for the carbon fiber, what do you mean? No, carbon fiber is just, that's actual carbon fiber. This is actual carbon fiber. So yeah, I based those on that model, and then later on, I discover the holes are in a different location. So we'll have to correct that. And if you look, a testament to the accuracy of the model, right? So this distance right here, from the rear to the transfer case, God, I keep calling it different stuff. It's about 5.5, right? So we got 5.5 millimeters from this flat surface to this flat surface. 5.5 millimeters. Well, turns out my numbers is wrong. So if I measure from this flat surface to this flat surface, I got 5.05. So therein lies the error. See, the thing is, like, this hole right here, same place, right? For this one and for this one down here. There's a pin in it down here. Same location on the XY, right? For the centers. And these are the holes that need to move to the right by about 0.5 millimeter. Son of a bitch. So I gotta move all this crap 0.5 millimeter to the right. See, and what it ended up doing in the end run, and I didn't discover it until like freaking yesterday. What it ended up doing in the end run is that the main spur gear is way too close to the part that I made. Way too close. This actually still spins though. Actually still spins just fine. It spins loosely in its location. I can't get my hand in there to spin it, but it does. It does spin, rest assured. I don't have the bearing installed. I don't know if the bearing would fit. Probably wouldn't. So yeah, it's not time for time travel, because I can actually kind of time travel with Fusion 360. Haha. But no, moving these holes, at least I have methods for that. I need to make that hole smaller as well, because there's no grip on that screw. and I can't support the bearing from this. Like, I have to have the bearing smushed in that way because that's what it's there for. It's there to stabilize the main spur. So, and then the motor I need to move to the right just a little bit, and I need to give a bit more of a gap in there because right now the motor is, you know, bursting these things out on either end. I thought I gave it a little bit of a gap, but I guess I did not. And then also these screws need a bit more distance to go up into there, which means I need to alter my sliding piece that I designed. So I need to alter that so that the screws fit in properly. We got some work to do. Got some work to do, chat. Of course, 3D printing parts this small was not easy. Any overhang like this on these slots was sagging downwards. This actually printed out just fine, but I had a lot of trouble printing the piece that holds down the servo motor because it's so small that it would just jump off of the bed. The opaque gray filament, while it is very drama-free, it does not stick to a glass bed as well as the translucent stuff does. So yeah, I've had a lot of trouble with that. Now you may wonder, is this servo, and this is why I put it in here, is this servo enough to run the steering? It turns out yes, and it turns out when you spend that much money on a servo, you get what you pay for. This is a very nice servo in my mind. So I'm gonna plug in this receiver just as a test, and I plug that into the steering. I think the steering is channel 1, is that right? Plug that into there, turn this puppy on. This is like a nice servo. It's actually very, very smooth in its travel, and it's fast. At least as fast as I am in terms of how I'm gonna be steering this thing. In terms of strength, I mean, it's not great, but I think it's enough. Farhan Iqbal! This is a thing. Yeah, that's definitely a thing. The servo saver is, of course, still crap, and I had to drill it out in order to get it to fit that servo. Nothing insurmountable, but I mean, you know, it's still annoying to have to do. Like, the servo saver barely does anything here. There, that's the servo saver doing anything it can to try to save your servo. It's not that great. That spring is way too taut. But it works well. So at least that test is done. I had to clip away and file away some of the plastic there, but I've actually corrected that in the drawing already. Yeah, pretty good. All right, let's hold on. Bop. Let's go to burn the subs. Let's burn Farhan Iqbal up on the board. This thing is gonna fill up soon. That's when projects are gonna take a turn. I'll have to get this thing okay, so removing this thing from the wall is gonna be really creepy to me because my wall is gonna look totally different after it. And then I'm gonna probably find a live edge board that is about the right size, maybe smaller live edge board, and we'll fill it up faster. And then we have to figure out how to outline that in the drawing, in the PNG image that I load up into the Raspberry Pi in order to tell this thing where not to place names. You know, probably photography is probably the way that I'll get around it. Really, Farhan? You gotta be all the way out here on the fringe. Farhan Iqbal, welcome to the board. Surprised it wasn't already replaced. It's getting up there, but you know, there's still open spots. Every now and then we run into a name that's difficult to place. We have a theoretical limit on the number of names, and we're a few hundred away from it. So, thank you so much for subbing. You're by Panic at the Disconnect. Goon Pontoon, Subwolf Plays Games. Another Junglist. All right. So yeah, back to RC stuff and servos. Some of the names on there are questionable. Hey, Twitch allowed them. That ain't on me. That's on Twitch. Twitch allowed those names. It's like tradition around here for me to put something else up in front of all of my bad behavior. You know, like putting Metronomic up in front of the copyright bots. I put Twitch's username system up in front of my own TOS violations of having absolutely terrible usernames. Yeah, this servo works well. I did not know that this was a fairly common replacement servo for the mini Z-sized 1/28 scale RC stuff. It is a lot more compact than this thing. It's about 7 millimeters, which this is like 14. So I think this is actually, what is this? What is this? Because I couldn't find a 3D model for this thing, and I couldn't find a place to source new ones. So yeah, it's 11. So 11 millimeters versus 7. So that gives me 4 more millimeters for my circuit board, although I didn't really need all that much vertical space. Although I guess if I want to keep the JST connectors, I could use that height. But still, I mean, it is smooth as hell. Like, that is smooth. So $40 servo, yeah, it's expensive and that sucks, but it works pretty well in the application. So I guess we'll continue on with it. Also, it turns out that I need complete clearance. Like, that is right up against that post. So that's up against the post. That's almost up against the drive shaft. So this is maximum everything. I think putting the circuit board up to this limit is going to be bad. I'm going to have like a partial hole there. Same with on this side, have a partial hole. That, or I could put standoffs on this and mount it a little bit above the servo. Not sure which one I want to do yet. So yeah, steering servo is approved. This is groovy. This is that expensive super duper metal servo with the racing stripe. All right, so let's correct our mistakes, our horrible mistakes. Measuring, and getting the wrong answer over and over again. And it turns out the wrong answers that Jesus Christ, shut the fuck up. Insulin pump. Look at this. This is a non-warning. A high blood glucose was entered 2 hours ago. Just because of that. Because of that, which was my morning coffee, I get that warning. And I can't, it's indistinguishable from the other warnings that the pump gives me. Like right there, I was going to make a decision about whether or not I wanted to give extra insulin, because typically when I eat, it'll spike up and go hyperglycemic, and then I'll have to make a correction decision based on that. Same beep as it telling me, hey, a high glucose level was entered 2 hours ago. So I get these non-warnings that sound just like regular warnings, and I have to treat them the same. It's so annoying. It's like getting a prank phone call. All right. Anyway, back to this. So we have all the things we need in order to correct the drawings, and then I've got more data points than I had before. So let's oh, that was BTS. There you go. So yeah, let's figure this out. Let's correct some of the mistakes on this thing. Where did I put the battery? Over there. That's just my test kit. It's a 1-cell battery, but it's enormous. And yeah. I would love to put a charger on this board. Put like a USB-C socket and a charger. Nah, I'm not gonna do that. That's what the Mario Kart has. It's got USB-C socket on it. It's got a much larger circuit board though. They had plenty of room to put their Raspberry Pi W clone, 0W clone, and then put a USB-C socket on the side that charged it up. Those Scandinavians are very clever with their design. Their test car, by the way, for the Mario Kart home circuit was basically a WL969, the drifting cart with the solid axles. It was this kit with a Raspberry Pi 0W on it and a Pi cam. Skip the sugar on the morning coffee. Do you really seriously believe that I'm having sugar with my morning coffee as a diabetic? You really seriously, did you think about that at all? I don't. I have Splenda. Okay. So yeah, that lines up, and that's a problem. So let's make the correction here. So I need about a 0.5 millimeter on everything. So I got to go back to the parts. See, the way Fusion 360 works is you're on a timeline for all the stuff you make, and the best way to put together a large assembly is to make a collection of components. So that's what all these things are. Now you can edit the components in place and stuff. I can actually go into like the bar here, and I can right click on it and I can do edit in place. And that makes things look cool. You can toggle associativity, edit and place menu, top of the canvas, blah, 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 blah. Okay. I don't need to do this right now. I'm not going to do this, but that looks really cool. It's like we're in the Matrix. One thing that Fusion, in my mind, excels at is looking really, really awesome. When you put all your work together and you've got a lot of shit going on here, it looks really fucking cool. Like, that looks so cool. The appearance menu is one of my favorites in Fusion. I took their stock carbon fiber, by the way, and I turned down the reflectivity of it by a huge amount. The whatever it is, like whichever one spreads out the light source on it, turn down the reflectivity, turn down whichever the smoothness or whatever, and that gets rid of that really terrible looking carbon fiber texture that they put on top. It had like dots in it because it would like oversaturate. Yeah, messing with the appearance menu is a lot of fun. I enjoy doing that. I don't have red filament though. I don't think I want to buy red filament, but if I had red filament, everything would look right. All right, let's get out of edit in place. How do I get out of this? No, I guess right click and do end edit in place. There we go. So instead of editing it in place, which, you know, I'd love to do, but I'm not really going to work on that, we'll open up the original file. Because the way that I build stuff this complicated, and again, the end goal of this was to get the motor and the servo in there. And actually the end goal, I can't do like whisper secrets with chat because of the lavalier mic. The actual real end goal originally and still, the next step, I should say, of this is to get a car body on top of this thing so that I can put a neat looking car body on top of it. I kind of like it like this. I kind of like the open chassis look, but it would be fun to put some kind of a weird car on top of it. Have like a weird, you know, not your typical RC car put on top of it. You say not your typical RC car, but a lot of people do that already. They do not your typical, you know, I'm not like other RC cars. I'm quirky and weird. All right, so anyway, the parts. I have a folder full of the parts. In the root directory, I have the whole chassis assembly, but then I keep all of my garbage in these parts collections, and I keep the stuff that I don't make in other garbage collections. So I've got a bunch of servos. So you can see, for example, that the common Tower Hobbies SG920, if I drop that sucker in there, of course I'm running out of space here because Fusion assumes you have a perfectly wide monitor. I could get rid of my face cam on this because I don't think I really need it, but I think we're okay like this, right? We're still gonna have to like measure stuff too, but it helps to keep you guys tied in the physical world, right? I mean, these windows are kind of big if you're on a 1080p monitor. Some people watch on their cell phones. It's like, how do you do that? How do you watch on your cell phone? I don't understand. It's like a lot of people too. It's very strange. The statistics that I get from Twitch, it's like, did you know that this percentage are watching on cell phones? And I'm like, fucking how? How? What are you guys doing? What are you guys doing? What is this? Anyway, back to here. So if I put the SG920 into the model, we could just immediately see that this is absolutely not going to fit anywhere on here. I'll just sort of loosely try to get it into place, but I mean, you just see here that it's just like, nah, that's not gonna fly. That's no bueno. They used to watch me on their cell phone. Oh man, I got all the notes for that wrong. Yeah, there's just no way that this is fitting in there. And this is a pretty small servo. It's a pretty common small servo. This is what we designed the pan car around. Well, that's what sort of turned me on to the, what is it, the K something or other? The KST servo. Yeah, much more space efficient. But yeah, I keep all these parts. By the way, I tried to look to see if the KST-08 would work, and it almost does. It almost does. It just puts the operating area. Oh wait, I opened the file. Hold on. That's not what I wanted to do. That's not what I wanted to do. Right here. So the KST-08 is the next size up. It's kind of a weird servo. It almost fits. It'd be kind of cool if I was able to run this, but It's a little big. I could almost get away with it, to be honest. Yeah, it's just that screw hole would be a no-fly. I could almost run the 08. Maybe one day I'll think about replacing it with the 08. The 08's, I think, a little bit stronger. And then I'd have to get the version that doesn't have a little wing on the side. But, like, that screw hole would not work. So I don't know what I'd do. You design around that, but, I don't know. I'll figure that out some other day. How much does that one cost? All right, let's get that out of here. Get that out of here before it becomes part of the revision history and I won't be able to delete the files. So yeah, in here in the wltoys folder, I have all my parts. And so what I'm going to do is I'm going to open up that cross beam part. Bop, 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 bop. wltoys bar is what I called it. Close that. So here is the part. It's hard to see because it's dark carbon fiber, but I have all the dimensions in the drawing now. So I'm going to go back to the sketch and edit the sketch. We've got a timeline down here. You can see what steps Fusion 360 thinks it took for me to create this thing. Drawing, sketch, that. Great. Okay, perfect. So I started these with a canvas. So I imported an image, traced it, and then extruded that trace. Now, part of tracing it is, of course, scaling it properly. So you measure a dimension with the calipers, and then you can use a calibration tool, calibrate, to identify two locations that you've measured very carefully, and then you give it a number. Now, the thing is, you can click anywhere on the X and the Y in order to calibrate it, and then it will send it to those dimensions and rotate it for you and all that stuff. What notes? What are you talking about? No. I don't do that. I don't do that. I wouldn't go into Tomatoes pre-stream or anything and just sit there and write down jokes. That's not something that I would do. Anyway, so yeah. Flatbed scanner, because it's a plate. Figure out the dimensions, turn them into whole numbers. That makes sense for how you would engineer something like this. And then extrude, and that's all it took in order to create this part. But then all of the institutional mistakes eventually bled down into the main model being just a little bit off, which is so annoying. It's so annoying. I mean, it's Zen. I really need to read Zen and the Art of Motorcycle Repair, because I base a lot of my thinking around that book in saying that, you know, somebody designed this. So there's a whole number somewhere in the design that somebody did for this part. That's the principle that I took to this entire thing. Onto the sketch. Are you guys ready for a nightmare? If I double click on the sketch right now, what happens is I go into the sketch editing mode, and the sketch editing mode exists on the timeline. So what I'm basically doing is going back to that step where I edited the sketch, which is before I extruded the part. It's important to be cognizant of that as you go around messing with your model. That's not, oop, cancel. So I have, okay, so the sketch palette menu is really annoying. I think I can minimize it like that. We need all the screen space we can get because of the restricted amount of screen space that I have, so that I can have my vanity cam and the desk cam up at the same time. And Fusion uses 100% of your horizontal screen space. Your editing window gets smaller and smaller, and I need a nice big editing window so that you guys can see what's going on. So the sketch palette menu, what allows you to do construction lines and some other stuff that I never use, and then finish the sketch, is permanently in the, you know, it would be nice if there was like something up in this bar, because if they put finish sketch up there, why do I have two finish sketch buttons? Anyway, I need to, their UI is really nice, but it still leaves a little to desire. By the way, if you have multiple screens, you just fuck this thing off to another screen. You just move it. All right, so It's my one prop joke of the day. I didn't even get it full screen in the clip, huh? All right, that's good enough though. Text is large enough. I'm just gonna leave it on the desk. My one prop joke today. Okay, so these holes need to be moved. We're saying 0.5 millimeter. Do we think it's like legitimately 0.5 millimeter? I think it kind of is, based on my measurement of this completely unrelated dimension. So these 6 holes need to move over 0.5 millimeter. Well, how did I generate these? By the way, the outside dimensions, the reason that you're seeing some of these lines are blue is because they don't have anything like locking them down to a specific location. Because the way that I created those was by basically putting a line on the canvas and then mirroring it to the other side. So a lot of that stuff is just floating in space. The main thing that I based the outside on was the location of this hole here. It's crazy, but and then a lot of the other stuff is a box from the center of the drawing. Very strange stuff. You can see all these little mirror restraints. So here's a 1 millimeter offset just sitting randomly out in space, but there's no mirror commands on that. Uh-oh. That might not be what I'm looking for. What did I base that location off of? Where are you guys coming from? Surely it is not. It is. 78.7. That's what I did. Oh boy. I measured from this end all the way over to this end, and those are 2.2. Uh-oh. Oh boy, this thing's getting a little hinky now. Everything's getting a little crazy. These are actually 2.2. Let's make those holes the right size. 2.2 meaning that they don't produce a friction fit on threads. That changes everything. See, here's all the stuff that I did wrong just coming back to bite me in the face. That's the radius of the outside. That's the radius of that. I feel like I measured that and I got the right number. I mean, obviously the projection on the scan is right. What do I get for the distance from that hole to the outer radius? This is like a moment of truth here for the basis of my drawing. 1.23. .15. Given the inaccuracies of the calipers, I'm willing to accept that. Especially given that, you know, it overlays on the drawing perfectly fine. So those are all expanded to 2.2 now. Under 2.2, that means that this distance is now, well, that should be the same. But my measurement of 78.7, I think, still stands. This is all messed up. This is all messed up, guys. All this is just completely messed up. 76.5. Oh, to the ends of the 2.2 holes. So 76 plus 2.5, 78. Sorry, plus 2.2. 76.5, 78.7. That number's correct. But it's still not in the right position. It needs to be 0.5 over. This seems like a nightmare. I'd hate having to do this. Yeah, you got to go over all your work and everything that you decided to do, and you need to revisit it. You need to revisit it because everything is wrong. This one is fine. Everything is in the perfect position. This is fine, and this one's in the perfect position. These are 0.5 off, but the measurement here, 78.7, because I've been through this and I've been redoing this part over and over again. 78.7 is exactly the measurement. Because if I go from here, and I'm just drawing a line in order to get a measurement. I could use the measuring tool to do this, but the measuring tool kind of makes assumptions sometimes that I don't like. And I go all the way to here, which Fusion isn't letting me do. It doesn't let me do that. You notice how it's skipping over the... It doesn't want me to over-constrain it. 76.477 is what it got from there to there. 76.477. It's so accurate. Why? Why are you so accurate? You're not correct. Oh, wait. Yeah, 76.5. Right. Remember? I'm measuring the wrong piece. This one doesn't fit. This is the one that has the holes that are off. So if I do that measurement again on the one that fits... Oh, I don't even have that hole on this one. Son of a bitch! Son of a... You... Here's a testament to how smart I am. You guys remember people said I was smart at one point? Here's a thing about how smart I am. I was measuring from... Get a pointing device because my finger isn't accurate enough. I was measuring from the edge of this hole right here to the edge of this hole right here. And you'll notice I don't have that hole over here. It doesn't exist. Smart. Okay, anyway, after we play the dun 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 dun. Okay, so yeah, I need to measure from a different hole. So I am going to instead measure from here. One thing that I know is that when you change the wheelbase of this thing, it is 4 millimeters. That is locked in. And if I do all the measurements on this thing, that 4 millimeters completely locked in. So 4 millimeters is the amount of distance that this can move, which is interesting because what they provide you with the motor spur gear, the main motor gear, is 5 millimeters wide, which means you can do that 4 millimeter adjustment without moving this forward or backwards. It'll just be meshing on the front side or the back side of the gear, or whatever you want to call it. I forget what you call that, the face and the toe or whatever. Gear terminology is ridiculous. It's like sailing. So yeah, anyway, I was measuring from a hole that didn't exist because I'm smart. So we're 4 millimeters between the holes. So we'll just add 4 to whatever measurement that I get. And so hole edge to edge, we're going to edge our holes here. Edge to edge is 79, damn it, 0.8. Oh, that's an interesting number. 79.8. That is 80 millimeter. When you come across 80085, really? Give me that 6. Come on. Ah, damn it. Come on, give me 808. There we go. That's more like it. Boob. Precisely 80 millimeters. Nice big even number. So you're starting to see that these things are designed in very even numbers. It was a very careful joke for not all that much payoff, huh? But I'm not about putting careful effort into a joke that has barely any payoff that nobody will get. All right, so yeah, 80, we subtract 4 from that because I'm measuring from center. Well, I'm measuring center to center. So we've got, oh, this is where the calculator comes in handy. And actually, I could go in here and I could type the entire equation into this, which is probably something, oh, it's something I already did. Something I already did. So we've got 80 millimeters minus 4 minus 2.2 to get to the center of the holes. We're actually at the front edge, though. Wait, we're the front edge of the hole, but our distance is front edge to front edge. Yeah, and we have to add 2.2 in order to get it. So it would be 80 plus 2.2 to get to the centers, and then minus 4. 78.2. That looks familiar, doesn't it? That looks a little familiar. That image of a hole overlaid over another hole. I'm not talking about your browser history. I'm talking about this guy on top of this guy. Hold on, let me get the other one. I'm trying to pick it up. Hyper gotchi. Oh, I'm getting a straight edge so that I can put these up against one another. Last camera's really washed out, isn't it? Really washed out. Game over, man. All right, let's do that. Gotta say you're from the 90s without saying you're from the 90s. Game over, man. Would you look at that? Yeah, it does look pretty familiar, doesn't it? So that's the this is the first step of many awful corrections that I'm gonna have to make in the next couple minutes here. So this is the first one. Finish that sketch. Luckily for us, none of the holes have changed. Now, excuse me, I can go back in time. I can go back in time with Fusion, and by editing the sketch, I'm essentially going back in time, and I'm editing the features of a solid that is defined by edges and stuff like that, right? And so if I make a change that puts like a line through one of my hoops, or if I have a complex extrusion and I move one of those lines or delete one of those lines, that will break stuff down the timeline. So the little chamfers that I put in and everything like that might sometimes break, and you've got to kind of go through and re-stitch the timeline back together. I'm not going to make a Loki joke. But anyway, you got to stitch the timeline back together so that Fusion knows what it's doing with the lines that you've provided it. And that's the main lesson of today, basically, is that, and the main lesson of today, and the reason that I have an educational copy that unlocks some features in Fusion 360, it actually unlocks a lot of features. The educational copy is pretty fucking lit, to be honest. The non-educational copy limits you in the functionality and the number of components that you can use. I would like to know what it's like to work within that limitation so that I could give you guys a better idea of it, but I'm also very much liking the fit of the pants that are known as the educational license. So, and the other thing is that I can't profit off of any of this. I can't profit off of my designs for Fusion 360. So if I wanted to like sell this motorboard, I don't think I'd be able to. There's a possibility that I could sell it as a sketch, but probably not. I would be working in sort of extra legal territory if I made money off of any of the stuff that I'm doing. So these projects are purely for personal development, but I am educating you guys about some of the finer points on Fusion 360, right? Never base things off faces. Never judge a book by its cover. Don't start a land war in Afghanistan in the winter. I don't know what kind of lessons we're getting out of this. Anyway, yeah. So that's correct. So everything else is going to be corrected, right? Using a model designed by Obama. I feel like he wanted to say "oh bother," but he said Obama instead, which is a funnier joke. All right. So anyway, those holes are moved and everything is fixed, right? Yeah, see that? Everything is, uh-oh, what's this? So we've got a little warning exclamation point, which is actually all the way up at the top, which means that stuff is updated. I don't know how Fusion 360 works when you've got multiple different people working on multiple different things. Those updates are fairly quick. I think you can share the directory and other people can work on a bunch of stuff. Guess who's back in the house? He was talking about. That song is the Obamas. Anyway, sorry. RuPaul randomly stuck in my head, which was based on the pumpkin dance overlay that I had. I think I still have that working. Is there audio? No, there's no audio on this one. Hold on. There we go. I can't actually hear that. It's like quiet here and I'm just like moving around. Anyway, so dumb audio bits aside, we have to update this. And I have a feeling that working with multiple people on parts and stuff can be really irritating, especially if they're constantly updating stuff. Like with the circuit board, you're supposed to be able to work on the circuit board and then have like somebody else working on the actual physical like enclosure, which I have to imagine is the most irritating thing in the world. Because if they move a mounting hole, everything explodes. And I'll get back into that a little bit more as I start designing the circuit board for this thing. I think I'll have more experience with that, and I think I'll have a better impression of how it works. I just remember that being extremely frustrating. Anyway, so back to this. Update the drawing. Update everything. Basically, get latest version. Thinking. Ba-bam. So it turns out that I gotta move everything forward. Well, we knew that already. And the reason that we gotta move stuff forward is because I'm a bad person and I do bad things, and I should feel bad about it. That's essentially the justification. Now, this location. I can boil this down to a number, or I can move the group of parts based on that location. I think what I'm going to do is I'm going to move the group of parts based on that location. So let me grab all of the components that I can get my filthy hands on. This is going to be a big move command. Yeah, bad things happen in Philadelphia. That's why. Exactly, Groovy. So here's the thing. Move copy is one of the most schizophrenic fucking commands in Fusion 360. And it really annoys me a fair bit of the time. Because if I just right click and I go to move copy, like I can click on a component, right? This is a component. It's a wheel. These are actually wheels that I've been meaning to print out. I've based them on the Volvo R wheels. I also have BBSs, and I should probably import the BBSs because those look a little better, but I've been using these as just like a simple size guide. You can't pass on the Swedish simplicity of a 5-spoke wheel. I like a nice clean 5-spoke Swedish wheel. Beautiful. Anyway, double click to select the entire, did you invent that? I based these on the metal wheels that I got, and then I have a template that I can use to make my own wheels, which is really fun. It's really, really fun to do. Making your own pattern wheels in CAD. Maybe my definition of fun varies from you guys, but I don't know. You're watching my stream, so you guys have to have a little bit of that in you. All right, so I double click and I'm selecting the component. It's highlighted over here, right? And so I right click and I go move copy, and then, okay, it did it this time. It selected component, but when I click on a component and I try to move it, it'll select bodies, and you're not actually clicked on a body. You can't move it around. I'm here for tomato jokes. I don't steal. I gotta stop doing that joke in the small window, but yeah, I'm not. Look, I wouldn't put that much effort into just a one-time joke that only 3 people get. All right, so anyway, select components, and now I get to click on about 60 different things that I want to move around. This is just the way that I've been doing it. I don't know. We haven't had any like Fusion 360 experts wander in and tell me that I'm doing everything wrong yet. I guess because I haven't really done much yet. So I got to select all the stuff that moves with this. Yeah, usually there's a fair number of experts in here to tell me precisely how I'm violating the Geneva Convention by doing things a certain way. Also, how's it going, Pickle Liquor? I feel like I'm poaching all of the tomato viewers. Okay, so all of this stuff is associated with that rear axle. The licensing issues concern me. Yeah, me too. People buy it because time is money, so it saves time, saves money, but I'm worried if I'm ever dependent on that kind of solution and getting burned if they do something I don't like. That's the thing, is like you buy the licensing and then you store everything on the cloud. I'm a little worried about that as well, because if anything goes wrong with like my license, because I'm in kind of a gray area. Everybody can agree. Oh, by the way, if you're moving a bunch of components, do not click this one. Don't click this one. I don't know why the fuck it's right next to this. Like, this is your generic move command, right? This one gives you this thing where you can rotate, move, and do all kinds of other operations that are really useful, right? So generally, I'm clicking on the arrows in order to move stuff on a particular plane. You can see that this arrow is offset and turned a little bit. So if I move this based on the arrow, that's going to move diagonally, which is totally useless to me because everything I'm designing on kind of like a plane, right? Extruding on planes and all that stuff. I want things that have right angles. Moving it in that direction would be completely, utterly useless to me. It chose some random ass vector. You can put the hyphen wherever you want, and it's still accurate. That would be completely useless to me. It found something at a weird angle and it wants to move it. So I want to correct that. I want to make that on the cardinal directions. In order to do that, my workaround is to click one of the other types of move. But if I click this one, it will deselect all the stuff. So if I spent a bunch of time, which I just did, selecting just the precisely right components, and I click on this one and then click back, it will unselect fucking everything. I hate it. It's annoying. But if I go over to point move, it'll still allow me to select all these vectors. You can see the star was there until I reminded it. And now it wants me to select a point to move it from point to point. But there are no points over here. In order to do the point-to-point move that I want to do next, I need to get to points that are hard to get to. And I just want to move this stuff out of the way. So I will do this command again, and now my little compass, or whatever you want to call it, is now on the cardinal directions. Why not select the set pivot? I don't know. I don't know what that does. I'm afraid of it. You'll notice that some things I am afraid of clicking. So anyway, I moved that thing off and to the end. Does set pivot put it back on the axis like I was talking about? Maybe that's what I need to do. I don't use this software and the button being and the button being next to it annoys me. Yeah, it's now stretch limo mode. Actually, it's probably more accurate to regular car bases, because remember we tried to overlay bodies onto this thing and it just wouldn't work because most cars have a much wider wheelbase. Oh, really? Let me try that and see how I hate it. Like I said, we're gonna get the Fusion 360 experts in here to tell me what I'm doing wrong, which is useful. So components, and I'll select, yeah, just like a random ass fucking pivot. Oh, so it lets me select my own. What the fuck is... Okay, who told me to press that button? That button is cursed. That's... Whatever that is, that's... No. That's just no. Whatever that is, that blew everything up. Everything is weird. I'm never touching that button again. Cancel. That button is cursed. There's a curse on that button. It's an ancient curse. And I'm never going to deal with it. All right, so, we're going to move the motor separately, by the way. I am going to move the motor, but that's going to be a separate move. I want to move it back a little bit, and then we can give it a little bit of a wider berth. So yeah, anyway, I'm going to reselect all that stupid crap that I selected earlier. Have you tried Tinkercad? Ban. No, I haven't tried many other CADs. AutoCAD, I'm an engineer. I'm an electrical engineer. I'm an electrical engineer. Please forgive me. It's fine. Don't worry about it. I'm in the Northeast. We take the piss all the time. I'm an electrical engineer. I am. Hey, Mikey Double T. Just subbed. It's a little... I made these smaller because they were kind of blurry on my monitor. Try it if you hate your life. I almost died when using it. Let's put Mikey Double T up on the board. But what I want to mention here is that I'm an electrical engineer. I went to Drexel University in Philadelphia, and I cut my teeth on AutoCAD. I literally cut my teeth on AutoCAD. Literally. Now, no self-harm. I cut my teeth on AutoCAD, meaning the first CAD program that I used was Command Line AutoCAD. We got Fusion 360 here, and that is works like AutoCAD. You make a drawing, you extrude the drawing, and then you do some little crimscrams on the 3D shape that you've extruded. When you build stuff, for instance, in CAD programs, you do it in kind of the same way that you build the device. Kind of the same way that you build it, right? Because, I mean, with a 3D printer, you would start from a base and you would extrude it. If I were making metal parts, it would help to start with a block and turn it into the part. You don't always do that, but it's worth thinking about, right? So that's the way that I know how to do stuff. Mikey TT, thank you so much for the sub. I really appreciate it. You're right by deadly hemorrhoids, which is a horrible thing to tell somebody. Hey man, did you know you're in close proximity to deadly hemorrhoids? Sounds like a medication commercial. No, don't copy the floppy. You're not supposed to. Don't eat the. I'm gonna cough. Hold on. Cough. Terrible. It's because it's so humid. Side Beach, thank you for following. I've used DOS AutoCAD. Yeah, ours was like Windows 98 AutoCAD. First CAD I use OrCAD. I hear a lot about OrCAD. Arrows to move the cursor and components. That thing was slow. Yeah. Having a nice can you fix my broken monitor? It's the power supply. Dracnet, that's a perfect opportunity for you to learn how to solder. You need to open it up, take a look at the capacitors, see what you got. Hey Pyro, and hey Three Mares. Three Mares gifted a shit buttload, a buddy shitty metric load of bits during the off time. And I thank you very much for unloading them on me. In my day, we use manual CAD. I typically do manual. I mean, that's how this thing operates. The milling machine that works off of Bother CAD, which is a sticky note. Anyway, I started with AutoCAD for like Windows 98. That's a lot of bits. Yeah, it was a lot of bits. There were a lot of zeros on that. Oh yeah, cardboard aided design too, much like Bad Obsession Motorsports. If you guys haven't seen Project Binky, treat yourself to watching that on YouTube. Bad Obsession Motorsports Project Binky is like a landmark project. It's so cool. Yeah, and then I also use MS Paint. That's one of my favorite CAD programs. I use it to make schematics a lot of the time because Eagle makes very ugly schematics. I used to use crap, I forget the name. I don't know if it's called CirCAD. I don't think that's the one that I use. There was another like very basic, it's like some guy in Florida made it. It's a very basic circuit layout CAD program. Makes very clean schematics, but I wish I could get that kind of functionality out of Fusion. Florida Man CAD. It runs on meth! Yeah, so anyway, AutoCAD, it's just what I know. That's how I know how to put stuff together, right? And so I have been relearning a lot of Fusion 360 because I did AutoCAD Inventor for a little bit. I didn't do anything with three-dimensional design for the longest time, and it turns out electronics is kind of moving in that direction because when you build a circuit board, it exists in three-dimensional space. It has an X, a Y, and a Z. So it helps to actually be able to put together an entire circuit board and then have a comprehensive model of the circuit board you can design around. And so Fusion took in EagleCAD, and EagleCAD was what I used to make circuit boards. Fusion is sort of the way that I know how to design things in 3 dimensions. Peanut butter, meat, chocolate. And so I have been able to use this much to my advantage. And I'm going to continue to do that. So that's why I use Fusion. When people come in and they kind of go, you should use the CAD that I use, my favorite CAD, you should use it. Well, I don't, because I don't use your CAD program because I can't do this in your CAD program. And maybe I can do this in your CAD program, but it seems a lot like pulling teeth a lot of the time. And so this is all in one singular thing that I can put together, and I can make these gorgeous looking circuit boards that have at least a minimal amount of rendering on them, and I can fly around them in 3D space, and then I can throw them into my RC car, right? So that's why I use Fusion, and that's why I am not going to pay attention to any suggestions of alternative CAD programs, because I am still learning this one. I have, for like a minute, I looked at FreeCAD, and I tried to do something in it, and I couldn't, and then I just went, I'm gonna check out Fusion 360 and see what it's like. So that's where we are, because I use Eagle, and I use, if you use CirCAD or FreeCAD or free whatever Linux thing, fine, that's great. FreeCAD is a pain in the ass. Well, I wouldn't know. You guys can say what you want. Anyway, I know KiCad does model exports so you can load in Fusion 360, but it's an extra step. All of the free ones they're great. They might not have the user interface. You can use them all together. Yeah, from what I've heard, there's a larger learning curve, and it feels a little like, like I use GIMP instead of Photoshop. There, you happy? Yeah, the one that you can work the fastest in and sort of know what you're doing better, is the best CAD. So anyway, I've got all these locations that I use to design a bunch of different things, and so now I'm going to take all of this stuff and I'm going to put it onto the top holes that we just corrected, because remember, the 2 bars had different dimensions because the frickin' part was not built correctly. And I'm going to have to deal with that on this part in the physical world. But in order to get the proper dimensions for the wheelbase, which is super important later on, and to get these gears in the right location, which is super important, yeah, I'm gonna have to correct that. So all right, let's put everything into the right location, then I can talk about how I made gears. So if you'll notice, this amazing interface has decided to put the set position command up here. What this does is this basically tells AutoCAD that these positions in these locations, I would like to save a record of that. So most of the operations down here on the timeline are me just finagling things into place. You'll notice that if we replay the timeline, it will put a bunch of parts out and then they'll suddenly all snap together into place. Well, that was a bunch of different operations. I just didn't press the, what is that called again? Whatever, set position command. So I'm gonna press it there just in case, and then grab this stuff and I will relocate it onto the hole over here. Bop, bop, bop. Yeah, I haven't gotten into cam stuff. So components, you. Let's make sure we get them all. Every now and then there's like a tire left behind. Everybody. That outline looks weird because there's multiple bodies in this part. I should get rid of the old one. These little towers were 3D printed and they hold up one spring between them. But okay, so where are we moving this to? Well, I'm gonna use a point-to-point move because it's more accurate. I'm just gonna hit the bottom radius of the pin. So that bottom radius of the pin is basically a meeting location of these two parts. And so I'm gonna take that pin, I'm gonna put it where it belongs. Where does that go? That pin is in the middle hole. Ranklin, thank you for following. Appreciate that. Put that right on the bottom. Make sure I'm selecting the right thing. The bottom edge of that. Snap it into place. And now, I'm gonna just click OK on that operation. We'll take a look at what happened. Now, my spur gear is just fucking destroying my part, which is accurate. That is accurate. Let's just check over this distance back here. So inspect from, why are you not selecting the thing that I want you to? There we go. I had to find the 1 pixel. From there to there, ah yes, black text on a black background. 5.55 millimeters. It's all fives all the way down. 5.55 millimeters. Depending on how I angle this thing. 5.5-ish. Pretty accurate. Yeah, the metal ruler, Jacose sent these in, man, and thank you. I gotta thank him for fucking sending me these things. Because, like, having a miniature metal ruler that's, like, pretty freaking accurate, it's nice. It's nice to be able to just do this old school, you know? Put that right there. But yeah, 5.55 millimeters. So we've measured it against itself. There's one problem, though. There's only one problem. The bottom plate doesn't match up. We gotta fix that. Bop, 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 bop. 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 Close. How far did we move them? I don't even remember. I don't even remember how far we moved it from where it was previously. We can do a center-to-center measurement to figure out where these are supposed to go. I guess that's what I'm gonna do. Actually, well, we'll probably have to do a different measurement for that. But all right, let's just do this to, well, the problem is that's gonna go XYZ, isn't it? That's gonna be diagonal. Yeah, see that? Now I can do XYZ delta. That's kind of like a rare thing to be able to do, is the XYZ delta. It's like certain things you select will allow you to do the XYZ delta. I think it has to be like point to point to get the XYZ. So yeah, 0.5 millimeter backwards. That's like almost exactly 0.5 millimeter. That's crazy. All right, so 0.5 millimeter, I can't close my measurement tool because it's too tall. They did not expect you to have a stream-sized window for this program. Now you know, to be honest, I could probably do like a green screen style overlay with this, but I think that would mess up more than it would be worth, because I don't know. I feel like the shop behind me is like my co-host of this stream. Okay, 0.5 millimeter. Save this. Yeah, because if something moves in the background, then it would suddenly show up. It'd be weird. So yeah, 5mm back. So we got to take a look at the chassis plate. Go into my folder, find the chassis plate. See this whole project of getting all this stuff in here and making this like comprehensive model of everything, including a dummy battery, came from the old size guide that I made for the wltoys kit. And the size guide was the minimal representation of what was there. The minimal representation of what was there. Oh, it looks like a bunch of the parts have updated on this. I don't want to update them though. But yeah, it came from this janky model that I created just to put a body over the thing. I'm much happier with this model of as accurately as possible modeling everything. I could put bearings inside of the hubs and stuff if I really want to, but I don't think I'm gonna torture myself with that. Okay. So I want the basic pan for everything. So the chassis file. Get this out of the way. And we are looking at which ones? We're looking at the rears. The ones without the rounded holes. For some reason, whoever made this plate decided to round off these fronts. I don't know why they did that. It depends on what they were working from. So yeah, these need to be moved 0.5 millimeter forward. All of them at once. Which, I don't know if the pan really looks like that. I guess it does. So I've been through this a couple times. I've been through the ringer a couple times with this thing, and I've reinvented the locations for all these holes a couple times. If you look, they're all off by like 0.5 millimeter. Oh man, I didn't even see that. By the way, when you're looking down at stuff like this, it helps to go into orthographic mode. Dictator Tiger, welcome. Click on the straight up and down view up here in the cube thing, and there's a little arrow next to it that you guys can't see, and go to orthographic. And now I don't have parallax on the locations of stuff. Now I do, however, have parallax on the actual scan. So my scanner is not straight up and down. You can see there are shadows and there are like weird looking hole depths because these are all countersunk on the other side. So that like you don't really see the thing there, but you can see a little bit of like the edge over here and the shadow that kind of propagates. So it's not as good as it could be, but yeah, anyway. It's just worth it to use as a basis for finding out where this stuff goes, and then you can take the approximate locations and then boil them down into measurements. So here we have 11.55. A 0.55, huh? That just needs to become 12. Minus 0.45. So apparently 12 millimeters in was a magic location where they decided to put everything. Or is that on the wrong side? Hold on, wait. No, it's not on the wrong side, is it? Which one are we doing? We're doing these. And these need to move to 12? But like what the fuck? Like, look, see, these line up. These don't. I must have made an error in scaling it, but I didn't make an error in scaling it because I measured from this, because there aren't a lot of flat edges on this thing, right? The flat edges are your best bet for getting a good measurement. And so I took the ends of these little ears are meant to stop the A-arm from overextending. And I took a measurement from ear to ear, from the outside of the ear to the outside of the ear, over here. And I got a number, 96.8. And if I measure from ear to ear, 97. So I don't know if that's 0.2 off, but like some of this stuff is just not it's just not right. I was looking in the wrong spots and I don't know what to do. Anyway. Yeah, that's kind of the weirdness that I'm dealing with here. So yeah, I don't know if we should make it 12.55. It's 11.55. I guess we make it 12.55 and everything lines up. It just, that gap is like crazy. Let me think about this, because we make it 12.55 and then those push forward. And this location is completely accurate. This center dot, not center dot, but I mean this dot goes up through the bar on top of it. and then everything is aligned properly. What you making, Fixin'? I'm fixing my measurements on the drawings for this RC car pan. The 1/28 scale wltoys W989 kit. We're working on it because I want to. Been mounting a servo to this thing, a new servo and a different motor. But like, I'm running into some problems here where these measurements are, I've been refining them, but it seems like, you know, some of the stuff is just way off from where the scanner picked up, like these hole locations that are like wandering off into the distance. And that looks kind of like a scaling error. So yeah, maybe I scaled this drawing a little wrong. I don't know, a lot of my other measurements are accurate to the real thing though. So anyway, now that I'm done that, I can just like finish the sketch and it redid all of the other stuff. I just need to view the right stuff. So you need to make sure that your views are all properly managed when you save the file. Because if I leave on the canvas, it will put that canvas onto the component, and then the component in the main drawing will also still have that canvas. So drawings can tend to get a little bit of a mess if you accidentally leave on sketches and stuff. So yeah, turn them off before saving, save it. Now the component is updated in the main drawing, or the main assembly, I should call it. And I can update that version. And theoretically now, at the rear of everything, those are in alignment, and now these should be in alignment. They're not in alignment. Did I go the wrong direction? Why aren't they aligned? Fuck. What happened? Oh my god, I screwed it up. It was 0.5. That's what we measured. Have you tried 3D printing that plate to see how it compares? No. Cosmo Quest! Rating with a party of 18. How you guys doing? Working on 3D models today. We're messing about with Fusion 360. Yeah, you could 2D print it too. I miss my 2D printer. I don't have that anymore. I had a brother printer back in college, and it was a laser printer. You could just dump new toner into the cartridge. I handed in term papers with a line through them because the toner wouldn't deposit in the middle for some reason. And yeah, that thing did me well for a long time. And then Windows stopped supporting the printer. So I had to stop using it. How's things over at Cosmo Quest? Was something going on today? Did I miss a launch? I probably did. You guys are interested in space stuff, definitely check out Cosmo Quest, because they fairly regularly raid my channel, and I because of timing, I don't get to catch a lot of their content, but they do cool stuff over there, man. They're really good channel. Yeah, we're working on a 1/28 scale RC car, and I've been trying to redo the little RC car because it is absolutely adorable. I love this scale because at this scale, while in lockdown, you know, I have one room with smooth floors and one room with carpets, and racing a tiny little RC car around is entertaining while you're locked indoors. I don't really plan on taking this thing outside, maybe to do like an overall speed test, but like these RC cars going into a turn at a car on this scale, with the motors that are available, they overpower the model. So you could just gun it and start drifting. You know, put a tiny webcam in it. I do have one that I could do that with. I might just for fun, but I'm not, I don't know. I mean, so the original idea was to take the Mario Kart home circuit and take that augmented reality toy and put some pro gear on it. So it really advanced cheating, basically. I've kind of lost sight of that. I'm just doing this for my own purposes, just to have fun building a tiny little RC car, to learn Fusion 360 a little better, so I can put together big, complicated assemblies with some measure of confidence, and to do a little bit of a reverse engineering exercise. So physically reverse engineering an actual object in meat space. Because in meat space, engineers tend to want whole numbers, but don't get them. And so I've been kind of translating it from meat space to digital space, from unintentionally inaccurate numbers and oftentimes manufactured defect numbers into the perfect realm of 3D renders. It's been an interesting thing. RC cars vibrate like crazy, so cameras tend to be awful to look at if you don't have stabilization. Mario Kart home circuit was fairly good. It doesn't really vibrate around very much. I don't know. I mean, it should vibrate a whole hell of a lot, especially, I mean, in a gas car especially, but Mario Kart home circuit has no suspension, solid axles, and big balloon tires, and yet it's okay. I mean, it still kind of jiggles around quite a bit, but yeah, and it doesn't move fast. That's true. That's true. It doesn't really move very fast. The camera being close to the ground is more of how it does its job. Anywho, it's interesting that is inaccurate to what I actually have. I'm gonna have to remeasure some stuff. This is supposed to be right up against there, but the holes that I put down here are not accurate. We're still off. We turned it from 11. What did we turn it from? Let's go back to the sketch. Like I said, going back to the sketch takes you back in time. You can see how it's grayed out all the other operations here. We turned that to 12.55. It should be 12.05. That's on me. That's my bad. All right, 12.05. That moves back into place. Wait, Control Z. Okay, yeah, that's the only thing that moved. All right, go back forward again. Okay, so that's on me. That's on me. That's on me. I'll take that one. I'll take that one. I'll take the big L on that one. Save that. Go back to here, and let's update everything. Update all of my components, and then my holes move. Bop. Haha, look at you. Centered and good. So regardless of what is actually in the physical thing, in meat space, by the way, this hole lining up, this fills me with emotions. Emotions that I'm not prepared to handle with, or not prepared to handle. This fills me with emotions, having this thing line up properly, because I did not work from this. This alignment is worked from the distance between this face and this face, the distance between this hole and this hole, and then my measurements of the actual piece of plastic of this case, this casing, from me putting my calipers on this edge that I can't point out for some reason, to the front edge of that case after having measured a bunch of other bullshit about it. So all of this stuff lining up the way it does is a result of 10,000 caliper measurements of disparaging parts of this, just completely separate things all coming together and fitting properly. Yeah, when worlds align. I'm not gonna ruin my voice more right now. I'll do anything. Okay, I'm not gonna. That's a Kermit voice. I'm not shouty. There will be a couple days. I think. What's the date today? Yeah, a couple days next week when I can get a little shoutier. I'll have some days when I can actually like get a little louder. I have to use indoor voices or people think I'm getting murdered down here. So yeah, everything is correct on the drawing now, except things are just fucked over here, right? What am I drawing? Well, this is a WL989, the wltoys 1/28 scale 4-wheel drive RC car kit. I like it. I think it's a really nice kit. I really, really like it. I'm into outdoor anonymous small car racing. Outdoor autonomous. Everybody shows up in a mask and a cloak with a little RC controller. Indoor autonomous small car racing. You basically put a camera on this type of car, and then AI use the camera to predict where the next actions that you take. That's cool. So the wltoys 1/28 scale RC car was actually here, and I'll pull this up. Let's pull this up. I'll pull it up because I keep having to reference it. I keep having to come back to this. Mario Kart home circuit prototype. You can see what the Scandinavians did here. What they did is they took the wltoys kit directly. I lost my button. I lost my direct image button. I'm sad. See, I've got visit, and then I've got another link over here. and I can't direct open. I think that Chrome plugin broke. It makes me sad. The coolest thing about Mario Kart Home Circuit, by the way, is that you can basically make your own track. I think that's the most fun about it. The guy looks a bit of view, the same shirt, the guy on the Fusion 360 page. Which one is that? What are you talking about? Which one? Is there somebody on like the home page of Fusion or something? Yeah, what they did here is they took a Raspberry Pi Zero W and the wltoys kit and a Pi Cam, and they put it all together as their test mule to do a lot of software work in order to bring you Mario Kart Home Circuit augmented reality stuff. So, oh, the official Fusion 360. Oh, God, all right. I was looking up how to do shrink wrap in Fusion 360, and it turns out, no, that's a different shirt. I have a shirt that looks a lot like that, actually, be honest. Let's be honest, I have a shirt that looks a whole lot. It's a hell of a wireless antenna. Have I ever showed you guys about rubber ducky antennas? There's something very interesting about rubber ducky antennas. I had one rattling around the desk over here that I showed you guys earlier. If I can find it again. Hold on, I'm gonna find that rubber ducky. Rubber ducky antennas are interesting. They have an interesting thing about their design that I would like to show. I can find it, and I can't, oh, here it is. Well, here's one, and I'll break it. My beard is better. Damn right. You're goddamn right. All right, so rubber ducky antennas. Why am I calling it that? Why does he keep saying rubber ducky? I'm a software engineer. All I know is that a rubber ducky is something you talk to in order to do code review. No, it is not. Rubber ducky antenna. Call it that because they are these children's toys of antennas. They're used around a lot of people who are not going to be trusted to handle fragile things. An antenna is just a certain fraction of a wavelength, right? So the length of your antenna varies what frequencies your antenna is sensitive to. I say sensitive to because it doesn't lock you out of necessarily using a different size. Like, you can use a different size antenna, you're just not going to receive as sensitively a signal through an antenna, through RF waves bouncing around. Rubber duckies are all the same size. Now, oftentimes we're talking about Wi-Fi frequencies and stuff like that, but they can take on a variety of different frequencies. It's actually better if you've got a frequency like written or labeled on the bottom of a rubber ducky, because all a rubber ducky is a big rubber outer enclosure for a wired antenna. That's all there is inside of all of these. That wired antenna is going to vary based on which frequency this is designed to operate in. That's all it is. It's just a piece of wire. This is just a clever way to house a piece of wire and to keep it safe. Now, don't go breaking all your rubber duckies, because some of them snap together, others are like glued together. So you might permanently break your antenna. But I mean, that's all. Like, this whole housing is for this much antenna. It's for this much antenna. That's it. It just helps it be in the right axis, and it helps it kind of get away from the body of the enclosure. So yeah, that's all they got. They got a rubber ducky on the front of this thing. Basically what they did is they hot glued, quite literally, a bunch of components together in order to create a wireless, I suppose it might be Bluetooth or something like that, uplink from a battery-powered device, and then they took that and turned it into the Mario Kart Home Circuit. But we tried this. We took the internals of a Mario Kart Home Circuit cart, depicted here. We got the camera, we have their redux of that board with all the stuff included in it, and their one-cell battery, and we put that on top of the wltoys W989 kit. Thing about the W989 kit is that it's been cheapened. You know, the Mini Z, the 128, the prime example of the 128th scale RC car is the KuroKesu, I think, Mini Z chassis, Macabre. Anyway, this chassis is heavily modified. There's barely any original equipment on it because they cut all the corners they possibly could on this thing, right? The Mini Z chassis works extraordinarily well, and it's very fast and stable and high. It's got freaking anti-roll bars, for Christ's sake, and a 1/28 scale. That thing is like a $300 RC car. This thing was like $75. I think it's a little cheaper than that. It's like $50 on Alibaba or something like that. But I've spent a lot of money trying to get this thing to work the way that I wanted it to. And so we went to a Mini Z-sized motor. I went to a 1-cell battery in order to try to emulate this. A direct transplant of this over to this chassis netted a car that was unable to run forward because there was so much resistance in the drivetrain from bad, cheap parts. There was plastic on the differentials that rubs inside of the housing and stuff like that. So while, you know, I'm basically spending a little bit of effort to turn this thing into a good chassis, I think it might mean that I'll be able to plug this thing into it, although I'll have to redo my servo mount. But yeah. This is not lighter than the original. I think if we do the pan car chassis for the Mario Kart home circuit stuff, it will be lighter. So that would be another one of the advantages. Differential, lighter, and I don't think the wheels will grip better, but anyway, the goal is somewhat nebulous at this point. Basically, what I'm trying to do is get this model into Fusion so I can make a body around it. But yeah, that was the original thing. It's like, wait a minute, I know that chassis. I'm gonna buy one, and we tried it, but I don't know how they got theirs to run at all. I don't know how they got theirs to run at all. Obviously, there was a lot more work that went into it, but I mean, this is their original prototypes. It's pretty cool. Anywho, this is what I'm working with. So we move this thing forward, and it looks like, I don't know, maybe my dimensions aren't quite where they should be. Yeah, the original looks very heavy. It probably was using a 2S battery, I'm gonna guess. What's up, Pog Rider? I don't know. This might be wrong because what I've got in what I printed out. Ooh, that's bright. When I printed it out, it doesn't quite fit. that doesn't really strike me as fitting properly. I didn't model the back end of that wheel, by the way. It's just I just left it as a flat face. That's why it looks a little different. But that looks a little different, huh? Are there any VODs of when you started this design? I did actually. I did this entire design over the weekend. I should have. Look, I should have recorded it, but I like to actually like have a little progress on the stream, and I don't want to just become an RC car channel. But I don't have VODs of starting this design. The wltoys thing goes back a long ways. You know, it started as something a lot more clunky as this, but basically since Friday, I took a scan of the base plate, the carbon fiber base plate that I ordered. Because I like this base plate. It has a switch hole right there. And it's carbon fiber, so it looks cool. So what I did is I took the scanner and I scanned it. And then I imported the canvas into Fusion 360. And then I made a drawing on top of this. Well, basically, I scanned this into Fusion 360, and I calibrated it. You right-click on it, calibrate, and then you select 2 points. So you have to very, very carefully select 2 points on this drawing, and then you can give it a dimension. And once you do that, it will scale your drawing. So that's where all the problems started. That's where all the problems started. Trying to get the rotation correct, trying to get the scale correct, so that I could then figure out where all these holes are. And so as you go, you try to assign it regular numbers. So 10 millimeters for these things. 9 millimeters for that one. Those holes were a complete mess when I put them in at first. And then I went back and forward and back and forward and back and forward until finally I had a design with whole numbers. And actually a lot of the outer like curves and stuff are not, they're just based on that scan bed. So they're not quite accurate. But refining the parts where it counts in order to get those to meet up properly. A lot of work. It's a lot of work to do this. I feel like I should take these models and like apply physics to them and then put them in like a game. Oh, but then my license would be invalid. All right, anyway, I don't want to save that. But that's how I got to where I am with this thing. What's my studies and work background? Why do I got to submit a CV to my chat? Why is it that I have to submit a CV to my chat, huh? God damn. It is down there, some of my work history, but I got a degree in, do you want my GPA too? Like, what is this? So basically what I do, I got a degree in motors and control systems from Drexel University. I worked for several years, 8, it felt like 10, 8 years with Booz Allen Hamilton, a big consulting firm in DC, and then 2 years with oh god, I forget. I had some background in architectural engineering as well, but I did motors and controls, which is an electrical engineering thing. I went into basically circuit design, reverse engineering directly out of college for many, many years, and I was extremely good at it. I was one of the best. I went from that to tracking devices and systems engineering with tracking devices. And then I went into medical device design. And then I got ousted from that company because I was with the manager that brought me in, who's going to be the new CEO. And they suddenly decided they hated him because he was thinking weird. And then I tried to find a job in the Northeast. Didn't. Started streaming. And now I just steal Tomatoes jokes in order to get viewers. Yeah, that's basically where I am. So anyway, that's my CV. Are you thinking of fucking hiring me? That's the last time I'm gonna go over that for the benefit of my audience. People look at what I'm doing. People look at what I'm doing on Twitch, and I'm kind of like filling a niche. I noticed there were not a lot of like makers and creators on Twitch a couple years ago, and I was sort of in a position where it was like, well, I can't, like I've spent all of my money continuing my insurance, and I was gonna like buy a house. That didn't happen. So I spent all my money continuing insurance, and that allowed me to get on a public health plan. And now I've got this wonderful situation where I'm doing my own thing, making my own money, but if I make too much money, I get right over a little limit there, and insulin, the cost of insulin does not meet the amount of income that I have. Not even thinking about fucking food and all that shit. So here I am. This is what I'm doing. It's not something that you should try to, don't follow my path. If you want to work on this type of stuff on Twitch, it's not worth it. That's where I am. That's what I'm doing. Welcome to Obother's channel, where I have to say that every week. Okay, anyway, I went to Streamer U, yeah. Literally, I don't know what any of my colleagues are doing at all. Like, fucking nobody has bothered to contact me. I don't know what it is about fucking millennials, but I guess I could go on LinkedIn and figure it out, but this is interesting. So I've run out of room over here. So we moved everything back into position, and now I've got an accurate representation of where everything is. I have already designed these parts, but they don't work. This is actually up against itself. So I want to figure out if my dimension from here to here meets up with the real world. By the way, in order to make these gears, there is a tool in Fusion 360. I don't know if I went over this. I've probably been over it 3 times already. There is a tool in Fusion. Are we still in orthographic? Jeez, always messes with my head. Red Plux. Thank you for following. And Equins. There's nothing for me to grasp on that name. In order to make these gears, by the way, this was not like a Herculean effort of mine in order to make a repetitious pattern around a central hub. I didn't do any fucking thing like that. There is a tool in the add-ins, scripts and add-ins. There's actually an app store too. You can actually buy plugins to make different types of gears. There's a lot of free apps, but apparently Fusion has an app store, which I'm actually okay with, because people will make scripts that can create 3-dimensional parts, and I could pay them to use those scripts. What was my SAT? I think I got fairly good SATs. I had to take it a lot, though. I tried to take the GREs. Those are a nightmare. But yeah, anyway, run the script for Spur Gear, and you give it a bunch of information. And I actually learned that the module 0.537 is what... the module for these gears is 0.537. What the hell does that even mean? Well, I had to look up a bunch of stuff about how spur gears are made, what goes into creating them. And it turns out the number of teeth times the module is the outer radius of the gear. That's it. That's it. It's that simple of an equation. So all I did is take the calipers, measure the outside of the gear, and then laboriously count the number of teeth that the gear has, which is just a pain in the butt. That was really hard to do. I had to do it like a pencil line on one of them. 1, 2, 3, 4. Eventually got it somewhat right. Put that module in both gears. So for a gear to mesh, they need to have the same module. They don't have to have the same outer radius, but the same module, because the module defines a bunch of other stuff too. So same module on both gears, outer radius module, there's your gear. And it just rendered it, you know, given depth and the shaft size and stuff like that. But yeah, that's how I did it. So that was kind of cool. It was a very easy way for me to make accurate enough spur gears for me to put into the model. It's like, I don't care how many teeth this thing has. All I care about is the radii and the clearances. So took the ACT and SAT once each and it was good enough. I don't know, man. I'd take it many different times. I went to all kinds of prep schools. All right, here to here. Let's get that dimension real quick. So I've got a gear sitting on one of these little transmissions, and I can measure it, and we can try to figure out the accuracy, because this is not matching the 3D model. There's problems. You got to figure out where those errors are, because those errors will compound into other parts of the design. I need to have an error-free design, which is a lot to ask. It's a lot to ask, especially out of me. So yeah, that's sus. Ow, I just poked myself. Well, I guess I deserved it for saying sus. This is like, the calipers aren't going to get in there. I wonder if we're going to get a better measurement this way. Four millimeter? You guys say that's about 4? I'm saying that's about 4. 1, 2, 3, 4. It's a little more than 4. See, the problem with my calipers is that the inside measurement, whatever you want to call it, claw, is just a little bit off. 343. See, it's just a little bit off. It's not good. They were getting stuck, and so I had to kind of like mess with it. 3.6. Does that look more like 3.6? It looks like 4 to me. Yeah, 4. Problem is these ends are like, they bulge out a little bit. So I got to go from a face that I know doesn't have weird dimensions. That's looking like 4. I'm gonna call that 4, and that way we have a little bit of wiggle room. So let's check on the model itself, on the 3D model. Face to face. I can't see it. It's 4. Son of a bitch. Well, then where is that space coming from? Unless, no, we just measured it, 4. So why is this thing moved in so far? Leaning forward a little bit? You know, I think the motor is pushing my mount forward. Yeah, that's got to be it. It's the motor itself is pushing the mount, it's leaning the mount forward. If you look at that, let me get the motor out of there and see how that lines up. Actually, not easy to get the motor out. Let me see. Okay. Let's get the motor out of here and see what's going on. I think this is pushing the two things outward, and that's what's causing the weirdness. I don't know about you guys, but I'm enjoying this. It's kind of neat to be able to come up with stuff like this and then have it actually go into the physical world. Probably should get a better example of a motor. You know, maybe we should pull the motor out of the the other chassis. Yeah, let me do that real quick. Let me get the motor that matches. Hold on, I'll read your message in just a sec. This is the pan car that Shortlurker was working on. I do want to reinvent the pan car and have it, you know, smaller servo and better stuff, but that's for another day. Yeah, it's entirely 3D printed. Glad to see CAD stream, specifically working with electronic components. Hell yeah. Yeah, that's the goal of this, is once I get this chassis all worked out with the one cell motor and everything that I want to use, my end goal for that is to be able to design a control board that's going to fit in this area right here. And I've already identified transistors, although the transistors kind of fought us in a way that I did not appreciate. So yeah, this design here is a 130 sized motor that we fit onto this chassis. So in order to get this out, what do I need to do? I think I need to, yeah, we got to just like remove one full side. This, by the way, is freaking awesome. This differential and everything on this. I'll get back to this eventually. It'll make this really good. Really feels like an undeserved area. Yeah, the area of sci-fi and tech streaming that I try to occupy, doing electronics and kind of having fun building stuff. It's a cool place, but it's tough to get footing in it because it's niche. Sup, nerds? Hey, Sir Fuglesang, what you got to do in order to make it out here in this crazy world of science and technology is you have to incentivize people to subscribe to your stream. Once I come up with a good idea for that, I'll let you guys know. Anyway, Sir Fuglesang, let's put you up on the board. Insulin pump is beeping at me. What's going on? What do you want? What do you want? Digesting my leftover Chinese food. Yep, that's what it is. It's getting a little hyperglycemic. All right. Yoink. I still don't know exactly how to say your name. I try. But my insides are quivering is right next to you, Sir Fuglesang. Same with Mythbusters. Is that an official? The Lone Stars over there. Have a good day. All kinds of good names. Approximately 1600, and we're approaching it. We're approaching 1600 on that board. Why is that distance different? That's what we're trying to figure out here. I got to disassemble this one a little bit because I want to get the motor out of it. I'll probably have to reassemble this battery into one single unit, and then I can do, I don't know, I can just place whatever board I designed for this on this, and then I'll have multiple functioning RC cars. Code Rushed, welcome to, I don't know, me being a little selfish and working on a project that I want to work on for once. How's it going, Code Rushed? We're building tiny little RC cars and we're modeling them in AutoCAD Fusion 360. These are my own custom Volvo R style wheels on this thing. This is just entirely an exercise in me being selfish. I should have probably removed the other side, to be honest. That was dumb. Let me put this all back together a little bit. Yeah, these are all 3D printed. This one is the entirely 3D printed pan racing car. From what I hear in official RC car stuff, I think they banned 3D printed like wheels. Selfish Works. That's the name of my, that's like my skunk works. It's called Selfish Works. Yeah, my 3D printer wasn't as well tuned back then when I built this, so. Not quite as well tuned as it is now. But yeah, we're trying to vet out some of the... Hold on, I was listening for where that went. Vet out some of the inaccuracies in the design, because I'm taking stuff from the physical world and I'm modeling it in AutoCAD and assigning whole numbers to things that may not be so accurate. We're trying to kind of get down to the fundamentals of how this thing is put together. And I'm running into some problems. Okay, I heard that thing bounce against the ground, and I completely lost... Oh, there it is. I found it. Found it. This is like a microscopic part, so I gotta be kind of cautious. Yeah, something dropped on the ground. That was indeed a drop. God, I need tweezers to work with this stuff, don't I? Yeah, all right. Get this thing mounted again. All right, so I'm going to remove it from the other side. I'll put these screws back in. I don't want to like lose all the parts for this, you know, because this is actually a fairly decent design. I would like to rehash a lot of the different parts, though. A lot of the lessons learned on this thing I applied to the wltoys kit. This basically, the way that we're mounting the 130 motor. See, the thing about the 130 motor, I should have... Fucking... God damn it. I'm getting mad. I'm getting mad at my own motor. The thing about the 130 sized motor is that it doesn't have screw holes in it. You talking about OCD? What are you OCDing about? Mine's going to say something mean, and then I have to pretend that I don't, it doesn't get a rise out of me every time. That's showbiz, apparently. What I have is I have screw holes on the front and the back, and there are, oh, the drop. I have screw holes on the front and the back, and there are discs on either side that mount to those screw holes. The 130 motor, which I don't have an example of, has this D shape to the back part with a flat spot right there. I don't want to put plastic against this metal. I mean, I have to have plastic against the front piece of the metal, but I want this metal to be in more open air because I want it to be able to cool itself. This one has vents, but I don't think that's really gonna, that's not really gonna benefit very much. I want the magnets to stay kind of cool, and I don't want to house it completely in plastic. The flat spots on the top and the bottom of the motor sometimes are used to take up that torque, but I'm gonna rely on the little button on the back. So button on the back, lock it up, make sure it doesn't, you know, spin in place, and then I need to locate this hole in front so that I can properly adjust it to mesh the gears together. So I'm going to get this yellow motor out of here so I can use that as the example instead of the super duper motor. This thing I'll probably end up using, but it's not a good size guide. It's not a good example, especially on camera. So if I remove this side of this thing, I can get the motor out, I think. This is not a quick change system for the motor, is it? Not a very quick change system here. In the other versions of this thing, this is like based on the Scorpion RC car. Scorpion 1/28 scale Z car. People put like 3-phase motors in it. Short Lurker has an entirely 3D printed version of this that he put a 3-phase motor on. It tears shit up, tell you what. So that still isn't going to come with me. I need to take the axle off. This is like the most annoying way to get a motor out, and this is just like a footnote. Big Crews are amazing. Do they have quick change motors? In rally races, have you ever seen a rally pit in action? Man, they will change out almost the entire car. For 24 hours of lemons, we did a Subaru gasket job, which if anybody knows anything about the Subarus and their gaskets, you'll know how much of a pain in the ass that job is to do. The way that they do it is with this insane, it's like an algorithm that you need to follow in order to tension the bolts properly and squish the gasket in. So basically it was myself and a guy who does, he's basically a mechanic for like tanks and stuff. And we went around to the other teams that were at the 24-hour of lemons race. And, hey man, do you guys have like a gasket for like a Subaru motor? Somebody had one. Somebody had one. They were like, yeah, man, we got it right here. Like, holy shit, we found one. And so we took their gaskets that we randomly found, and we did this all on the Wartburg. And at some point, the judges were running around the paddock, seeing what the state of the teams were, because this was right when they split up the race into two days of racing, because there was a guy who died. He basically had like a heart condition while on the track, and it was a big thing. And so they're like, we can't push people this hard at the race. So they did 2 days of racing. This was in Maryland. And I ended up, or no, it was like deep in Virginia, I think, or something. But anyway, I ended up going there for a friend of mine's team. There we go. Jesus Christ. And so I ended up helping them with pit crew stuff. Yeah, but so we found this random motor. Or these random gaskets, and we disassembled the motor. And so we were sitting all around having beers just next to this fully disassembled Subaru motor. And so the marshals of the race come around, and they're like, what are you guys doing with all these parts? Did you guys disassemble your whole fucking engine? Like, yeah, we disassembled the engine. And we were all completely nonchalant about it. Like, it's no big deal. This fully disassembled motor. We're like, yeah, what? Like, you guys know you got to, like, race tomorrow, right? Like, early tomorrow? We're like, yeah, here we got it. How you guys doing? You want a beer? So we ended up doing like a marathon session of basically, I was basically reading the tensioning algorithm to this other friend of mine who was reassembling the motor like as fast as he could in order to get everything back and connected and ready to go. They ended up doing pretty well in the race. And then I think they got like the Mechanical Proficiency Award, which is one of the higher honors of the 24 Hours of Lemons race, just because of our nonchalance at having a fully disassembled motor ahead of a race. It was a good time. I didn't do a lot of the Lemons stuff, but I did help with the car assembly unit. All right, I'm trying to get this back together so I don't lose these screws. I'm stealing the motor because it looks more like the one that I put into the CAD model. I would love to do a full redesign of this, though. This is sort of the original concept behind, like, well, what if we put a Mario Kart brain on top of this? So there's still a possibility that I could take this and modify it to take the camera and the circuit board. All right, this thing goes back in here. We push that in a little bit, give it a little tension. Oh yeah, where's the flat spot? Oopsie-daisy. Find the flat spot on the axle. That's where the grub screw interfaces. So we get all that torque. And this thing back all the way on there. Meet those up. Then don't drop this on the floor again. I guess I'll use tweezers again. It's such a small lock nut. God, everything is so tiny, and my 3D printer is not that great at tiny. It's not that great at tiny stuff. All right, so that chassis is back together with no motor. Woo, bearings. All right. Yeah, time to get a resin printer. I'm not going to do that. I'm not going to get a resin printer. I'll make it work. Horizontally opposed 4-cylinder nightmare. Yeah. Spark plugs, drop the engine first. I'm just going to get the wires off of it, because wires are really annoying to deal with when you're messing around with this stuff. Let's go soldering iron. There you go. Yeah, so the eventual direction that this is going to take is me designing a circuit board within a set size of PCB. I'm going to have to get my entire motor control design onto a set PCB size with the radio and the gyroscope module. The gyroscope module is there for fun, because like if you take a turn, it can like correct, which I think is cool. And you can turn it on and off with the remote. So $600 to have 4 plugs replaced in my BRZ. Literally have to drop the engine out of the subframe. Yeah. It is a nightmare of an engine, isn't it? That motor is crazy go nuts. All right, so all of that was literally just to get a motor that looked like the CAD model. We're indulging today. because I've got a massive headache because I didn't sleep. So yeah, this motor going in there, it looks like, so if this were straight up and down, it still doesn't have the distance that I thought it would. Of course, the screws aren't going fully into this either. Makes me kind of think that my holes are off, at least, but these are all in a line from, so this one is a pinhole. There's a mounting pin here, screw, screw. Those are all in a straight line coming from what I guess is like the center of the, well, center on that axis at the very least. But like, is my measurement off? Because I measured here. So I guess we're gonna have to double check our work here. So I'm gonna have to check from here. So let's take, hopefully it understands what I want to do. From here, let's go to the edge, because that's what we've been doing. I love how unreadable these numbers are sometimes. 34.9. 34.9 from the edge of that hole to the edge of the model. Okay, 34.9. Put that on the clock. I couldn't possibly get a more accurate number for that. 34.9. Son of a bitch. Well, I mean, there is the inaccuracy of the calibers, but what is the thickness of that gear? Approximately. This one looks like it's been through hell. Jesus. Some of these look kind of worn. Are these the same gear? You'll notice I've got a lot of spare parts for these things. Got a lot of spare parts. It's because I bought a couple of them. I bought 2 of the cars, and then I got the metal hubs and stuff, and then I had to buy different springs specifically because the ones that came with the metal hub kit, the metal parts kit, the spring had where the plunger goes into the shock. It had like a plunger inside, but it was internally threaded. So the outer edge of the thing was internally threaded, and it had like a plunger bit that gets caught in the threads. It was the worst shock. It's right here. This is don't buy this. Same as my mate's V10 Audi, you got to drop the engine to change the plugs. Yeah, assume the service position. That's what we used to say. The service position being where you basically take the front bumper and it hinges open like a fence gate. This is the worst design shock that I've ever had the displeasure of trying to use. This is the worst shock. So this binds. I'm pushing it in as hard as I can. Right? I took one apart. I could just show you the internal workings of these things. They perform a walletectomy, a walletaptomy. Look at that. That is the worst design that I've ever seen. Absolutely horseshit. There's no way to make this work. This is what you get in the metal parts kit. Even though you get these wonderful, unbreakable metal parts in your 1/28 scale thing, these are awful. The ones you want, if you want to do a good little spring suspension, the originals are fine, but the ones that I got are these. They're slightly rounder. Slightly redder, slightly rounder. They have an external thread on the piston and a tension adjuster. So boop, boop, boop. They are much, much smoother. But yeah, the other ones are just bad and should feel bad. But anyway, what I'm saying is I've got a lot of spare parts because I have maybe made some bad purchases along the way. Maybe these the metal parts for these things are wider. They have a different, like, they move the hub out and they're a little wider, and so I had to do a bunch of stuff in order to reposition them, and I did semi-adjustable ball joints on these, but I had to file down some of the parts in order to get them fit. This has been a nightmare. This has been a nightmare. So anyway, that measurement is totally accurate. And I'm wondering why. Maybe I got the gear thickness wrong. What is our thickness here? 2.5. I want to say 2.5 millimeters on that. Take a look at our file. Let's take a look at the file. 2.5 millimeters. That would be this one. It's probably going to be exactly 2.5, right? That's what I want. I just want that. Ugh, not going to show me. Fine. We'll go from here to here. Aha! 2.4. Naha! I found you. That's my problem. See, this is what the gear thing created. Or no, I think it creates like a flat piece, and then you extrude it from there. So it made the drawing. Oh, my measure thing is open. That's why I'm not seeing it properly. That would be, yeah, that would be me cutting that out. That would be the drawing, and then this. Okay. Well, I can't go back through those steps, can I? I can. What? No. Okay, I have no. Okay, let's collapse that. Man, I gotta figure out how to make those in Fusion, the little timeline organizers. They're placebo shocks. They really are. All right, how do I make this 2.5 without ruining everything? I think I can hit extrude on the face. Well, I mean, if I press pull the face and then I take that step and I move it back in the timeline, I think that will allow for, you know, these operations to come through properly. I don't know if that's going to change that length, though. So let's, okay, so here's what I'll do. I'll press pull this face 0.1 to make it 2.5. Now that step's right here. If I take that and I move it back to here, that's going to ruin some of the other steps, isn't it? Yes, it did. All right, I get it. That one's fine. This one I need to redo. All I needed to do was open it up and it corrected itself, huh? And that corrected everything. All I needed to do was remind it of what I wanted to do. And then it was fine. Double check some of the measurements here. So I want to check from this end to this end. That's 2 millimeters. Double check. Double check. So we are on the smaller end. I didn't model the other side because it's a complicated part. It's got like a D-shape thing on it, and I don't need the gear interface to be 100% accurate. I just need some of the distances. 2.2. Check it again. .02. Yeah, I'm willing to say 2 millimeter on that. Okay, so that is 2 millimeters, and so now the outer size is 2.5. Could almost be a little bit more than that. So let's see if that fixes the gap that I had. This is so fiddly work. This is just annoying. Fiddly. We're futzing the numbers around, trying to get as accurate of a representation of this as I can. I really didn't do that much. Yeah, I'm still kind of wondering why they're up against one another. In the 3D printed version. So if I put this plate on top with the quote-unquote, I don't know, center-ish hole sitting there, and this thing's all connected to everything as it should be. That's mounted. It's not moving. All of my measurements are the same. It's up against itself. So this is, and the frustrating part is like how many numbers are wrong in order to get us here. How many of my numbers are off to get us to where this is? if you look, by the way, right here, you can see that the gap between the battery holder and this motor plate, pretty accurate to what's in the drawing. There's like barely a little tiny corridor right there, right? If you look on the model, sorry, wrong camera. If you look on the model itself, let's get the motor out of here. There's a little corridor right between those two. And that's pretty accurate. So this is accurate. This is accurate. That distance is accurate. Why is it not? This is just frustrating. It's just frustrating, right? I gotta get it all to match up, and it's just not. Now, putting this together under the premise that the print bed is right here. The thing that concerns me is that the hole for this bearing is not going to be very accurate as a result of that. I'll probably have to come back with like an actual, either an end mill or some kind of like probably a drill bit. I guess I could use. I don't know if I don't have any like flat drill bits, but if I had a flat drill bit or an end mill would probably be better, and just go through and just make sure to properly open that up, because the 3D printer is not going to, it doesn't put good support down on top of support material. If it's doing a circle on top of support material, there's going to be problems. So I will need to mill that out. It's not as accurate as I'd like it to be. I would love to print this thing from this surface forward. That's just not going to happen. And then the other concern that I have is that I have enough space for that screw to go down through all the surfaces. I haven't moved that screw yet. I need to move it. It's off by a little bit. Especially if I'm going to be reducing the amount of material in the front here. I just don't know what happened here. If maybe I altered it or something, but that I don't know, guys. I don't know where that gap is coming from. That's the problem. Now that we've got everything accurately represented, including the measurements that we took of this very part, it seems to be colliding. Why? There should be a gap there, a discernible gap. I should be able to see that gap. Huh. Well, mysteries that I may never solve. I could still work with it like this, right? And still work with it like this. Yeah, that's for the motor to slide back and forth. An offset. Yeah, those weird screws from that meme. I get why the motor doesn't fit. It's because of the inaccuracies here. This is busted out a little bit from the other print. So I should add a little bit of gap space to some of these parts so that they fit together properly. But then I do not understand why that, in spite of all of our measurement, is up against there. Super weird. What's the thickness of this part? Let's just check to see if these line up. 4.1, 4.2. 4.2. This guy over here. A little measurement from you to you. 4.225. Yeah, maybe this part. No, that's the same size. Ugh. Why is it off? We measured the edge of the hole that this thing is based on. I did everything. Screw from the side of the motor thing to space might be more effective than locking it from the top. But it needs to slide back and forth. And I don't want to have a screw. I mean, I could do a screw straight on this face to go back and forth. But I thought that would be hard to get to. If I just have one, I guess that could work. If I just have one there and I lock everything else down, I could do a piece that goes up and around, and then I can have the trough in the front, and then everything can be a little thinner. Yeah, that might be better, because then I'm not running into limitations on the amount of material down here, right? So if I do a screw into the base, and then I turn that into a slot. But the problem is, no, I can't do it on that side. I would have to do it on this side where the lip is. Yeah, I can't do that. I can't do it that way. The screw would have to be here, and there's a motor in the way. So you wouldn't be able to get to the screw unless I make this piece taller, which I don't want to do. The side of the car so it presses the motor into position. I don't like that. Because it needs to move horizontally back and forth to get the gears to mesh. Maybe I don't know what you're talking about. Maybe I just don't know. If I do like a screw hole all the way over here and it could move 2 millimeters back and forth, but then a piece would stick over the edge. Oh yeah, the other thing I need to do is give these a little bit more distance, the screws that go up through. I need to find that step on the timeline. The timeline is extraordinarily convoluted on this model. All right, so now here's the deal. The way that I design this is that these pieces have not been designed in another drawing. They are designed in the same way in this drawing. The way that I probably could have done it is taken selective parts into another drawing and then had my overall assembly and then have the assembly where I make these 3D printed parts. But I didn't do that. I put all the parts together and then I started designing the additional parts. That's why the timeline is nuts. Now I can turn these into components. That would be one way to do it. But the workflow on this is a little weird. I need to maybe do some corrections to the workflow and organize it a little bit more. I would really love it if they had like folders for workflows, like on the timeline. I'm not adding springs and stuff. I'm not going to go that far. You guys are complicating it a little bit much. Use that shock spring in order to push it over to the side. This'll work if I can just get this to be the right size and, you know, give it a little bit of space for the motor. I'm going to move the motor back a little bit, which will make this ring smaller, but it'll still, like, I barely get 2 millimeters of travel in this back here. But I mean, all I need is a slightly better screw grip on that. I'll think about how I want to do that, because I can't get to it from here, and I can't make that tall enough to get to put a screw on to give me that 2 millimeter back and forth. It would be too big to come in from the side. Think about that. Yeah, like how tall would it have to be? Let me just vet out this idea real quick. Even though our dimensions still don't match up, that's what I was trying to solve. So like, I mean, I could fudge it and maybe go into here and make it fit like that. And then no, actually I can't. It actually has to stick out because of the lip, because that would print against the bed. So this has to be here, which means it can't interfere with the motor, which means it needs to be all the way up here. And then I've got barely any material on either side. I have to make a sliding component that goes all the way up here. You guys are talking about just having like a long screw that just pushes the motor over. So you would have that just push it together. I guess. I don't know. I mean, that is a lot simpler. You know, just push up against that part. I don't know. It seems wrong to me. Yeah, it'd be like a John of Ice. But then I'd have to find the right size of screw or something, or do a threaded in. I wouldn't have to do a threaded insert. I'd just do a, you know, just make it small enough that that thing would then put pressure in there. And then I could potentially have a screw sticking out of the side. And that would be kept in place just with the motor size. Interesting. I'll think about that because it's not a terrible idea. A set screw from the pile of set screws. I don't know where those are. just have a grub screw in there. I guess I do have grub screws. I do have grubs. I could potentially just grub screw it. Yeah, you guys got a point. Maybe I should just grub screw it from the side, and then it'll just push it up against there. If I was doing this more professionally, it would probably be like another piece of plastic that would press up against it. It does keep me from printing these infernal ovals all over everything. The ovals are pretty bad. The Toy Beaver, hey, thank you for following. One from the top to lock it in. It's gonna kind of try to like push it inwards. You know, I think it's okay because, okay, so what forces are we up against here? Be ready. Yeah, I'm gonna have to project a point onto the side in order to locate that grub hole, we'll call it. Just copy the mount styles I put on Discord. I know you want that. Those are let me just get them real quick. That would be in stream projects. So I like to keep stream projects on topic because then I can reference conversations with ideas. We still don't know why that gap is there, though. That's what's bugging me. Here's the style that Short Lurker linked to, which I don't think I'm going to be able to do. It's a little parts heavy. So this would be like a sliding bar, and when you screw it into the base, it tensions. I would have to move the motor up for that, and I mean that would be just for the front part of the motor, but I have to move the motor up. I'd have to somehow get that to 3D print cleanly. I just don't know. I don't think it's going to work out for this. There's all kinds of styles though. Okay, maybe we do the grub screw. Maybe I just do the grub screw. Maybe that'll work out. So what I need to do is I need to clean up the stuff around here a little bit. There's still a bunch of stuff that I need to address. So let me get rid of the parts of the drawing that involve that screw. Let's just I can't delete it. Okay, I'm waiting for Fusion to come back to me. Oh, there we go. All right, yeah, let's get rid of the parts of the drawing that involve that screw. I'm gonna move the motor back, I think maybe 0.2. It takes so long for an assembly boolean, which I hope can cut in half and have all the detail inside. What? I have no context for that. What's that? What are you talking about? I don't know what you're talking about, Chernova Labs. Okay, God, what order do I even go in this? I mean, at some point I designed the back piece for this, the rear motor mount. In order to do that, I projected from the motor itself. So if I move this back at that point, then I will have more power to my name. This is, oh boy, here we go. This is what I wanted to show today, was the process of going through a complicated AutoCAD drawing and actually like altering the components in it and the stuff, right? Actually altering stuff. Shorty, did you see that servo working, by the way? The KST-06. By the way, the KST-8 almost fits. I was looking at that a minute ago and I was like, ooh, you know, I might have wanted an 08. The 06 is fine, but the, let's see, servos, the KST-8 is a slightly more powerful one, and it, oddly enough, very, very nearly fits. But the 06 is really good. I don't feel a need to change it, but I mean, like, putting these in the same location, like right about there, that actually fits, except for this one screw hole. I saw a bit, I think it looked like the plastic piece in the servo saver slipping. Yeah, it was, but not only when I made it slip. and then it's able to overpower the servo saver, which is good. And it wiggles a little bit in place, so I'll have to up the tolerances on that. But yeah, if I really wanted to, I can't get a mount out here, but if I wanted to do what wltoys did and make just like a little thing on the edge that holds it, I could probably do that. I could probably fit this servo and it would work. But I should stick with a smaller one, I guess. I don't know, the 08, I don't know how much the 08 costs. The 06 is like fucking $40. Hate it. But if the 06 works, I'll continue to use it. I'm wondering if the 08 works at 3 volts too. That's what I'm not sure. All right, let's get rid of that component. Anyway, yeah, the servo works pretty well for what it is. I got to think about how, if we're doing the grub screw, I've probably got a grub screw that's long enough. I'll have to find it and measure it, or I could just put a regular screw through the side of it. And then, what am I looking for? Grub screw from the side to just tension the meshing gears up against one another, and then we keep the back design. If I can move the motor early enough in the design, then the rear piece will just design itself. And we can go in and alter steps for the other one. It's got many more steps, too, to each signal interpretation. It's a very smooth servo. I don't know, I'm kind of sold on this company. I think this company makes great stuff. But yeah, the only thing that I see it doing is wiggling a little bit in the mount. You can only really see that under the microscope. But yeah, it's not... It goes up to its extreme, and it's like right up against that screw, but the servo saver doesn't show any additional gap, so it's not hitting. It might be a little bit slow, and I think it speeds up when you give it more voltage, but this is fast enough for this scale. And it's able to interpret even the spring bounce. See the spring bounce? Ready? Yeah, pretty good. I'm sold on these servos, man. And this thing is plenty strong for this model. I don't know what the force test on it is, but what do I do? Hold it by one wheel? It could bench press the model. I think that's probably enough to steer with. Hopefully you don't take turns like an old person. What are the gyros there for? I don't know. I don't know if the gyro is for grip driving or if it's for drifting specifically. If I do get one of those solid axles, the one-way axle, like get a solid and a one-way axle, apparently you can drift pretty nicely with these. My Footabaugh has an adjustment to dampen the wheel and the controller. Huh. Let's see if I can make something out of for the Fly Sky. Which one is that? But yeah, the SG90s don't fit, but the 08 is really tempting. That's really tempting. I could fit that in the model, but this is lighter and probably better, so I'll keep that for now. Plus, I also ordered another one. I'm gonna have too many of these servos. You can never have too many servos. Okay, anyway, sorry. Getting distracted. That's what this whole project has been. It's all just a big distraction, Bother. It's like you don't consider yourself a real adult, and you're just distracting yourself constantly. I'm gonna get into this drawing. I need this to be a slightly smaller hole because there's no grip on the screw. I need to extend the length of these screw holes. We need to get rid of this stuff, this garbage up here, which will get rid of some of the garbage down there. And then I need to place a hole here at the center line of the motor so that I can make a grub screw that'll push this thing over. Then we need to move the motor back just slightly and make sure, I mean, we'll move it back so that there is a gap here that appears to not really be affected. Like that gap is possibly narrow this hole so that it grips the front of the motor a little bit more snugly. But I need a little bit of space in here. The mystery of why this thing isn't lining up is crazy. And then, you know what? I think we need to move the motor back so that I have more plastic over here. Because the bearing mount Where are you? The bearing mount is not quite right. There's not a lot to work with in here. That's trouble. That's trouble. Okay, so let's oh boy, that's a lot of stuff. That's a tall order for this thing. Did somebody say grub screw? Yeah, I know. This isn't a laser level. It doesn't have 10,000 grub screws in it. All right, so here's the deal. I guess I'm just gonna go into the drawing. I'm gonna go into the sketch, and I'm gonna confuse the living hell out of Fusion 360. What is Sketch 12? Sketch 12 is my servo hole. Okay, I've been naming stuff because it's easy to get lost. So we're on the motor front top. Motor front top. And if I do this, all hell's gonna break loose. Because remember that our sketch exists at a point in the timeline before I did those extrusions. I have an assembly for an industrial evaporator that I want to cut in half and 3D print for training purposes. My CAD has been frozen for about 2 hours. Oh my God. What are you in? You're in assembly Boolean, which I hope can cut in half in detail. I gotta go back further. I don't have Chatterino, so I'm like just scrolling. Yeah, I didn't see your first message, but man, that sucks. Yeah, the cutaway views on something like this are much easier. By the way, this is orthographic view, looking straight down. It looks like a totally different, it looks like a drawing, which is amazing. I love this. This is super powerful because you can just take a look and see if your screws line up, which was part of where I discovered that I needed to base some of my, I should have based more dimensions off of this hole right here. Because this hole goes all the way down through the model. Brian on Twitch. Thank you for following. Hey, Brian is here. If I get rid of the drive shaft, it'd be nice to have like visibility holes and stuff you can mouse over. And then the bearing, which is this, you can see those two holes are directly in alignment with one another. That's what I should have based more of the drawing off of, because I don't think there aren't any other holes on this model that align these two chassis plates together. That's what I should have based a lot of my measurements on. Well, I didn't know that. This thing was basically designed around this interface right here. They probably started with the motor. Well, not because the motor height would change depending on where, but those are in plane with one another. So the way that they probably started this was with the concept of mini Z AWD transmission. I saw an image of this before where everything was laid out flat. Okay, I've been through a lot of Google image searches in order to look stuff up about this, and unfortunately, I can't repeat. I don't remember what the terminology was, but there was like a diagram of the. Let's do like mini Z. There are crickets that sound like failing capacitors outside, and it's creeping me out. I think it feels like something's about to explode, or like a transmission, or sorry, like a transformer is having troubles. It's like mistuned or something, but it's a cricket. I've known this because it did this last year. It creeped me out. It creeped me out, you stupid crickets. They just sound like electrical noise. I can't find the diagram. Mini Z AWD diagram. Pop. Oh my god, that's too much diagram. One thing I know Short Lurker did is he took these diagrams and he took them into CAD in order to reverse engineer parts. So if you can't find a part for something, but you've got a manual and a scanner or a PDF of a manual, you can pull these diagrams into CAD and reverse engineer them from there. I can't find the picture. Basically, the picture was the two differentials, a transfer shaft, and a motor with the two gears. And that looks like that's where they started this design from. was basically take those components and put them into position and then put a hole through it and then design everything else out from there. That's kind of how it feels. But yeah, this design is not supposed to be in contact with this gear right here. And yet, in the physical world, in meat space, we've managed that. Wait a minute, what the fuck's going on here? Uh-oh. Oh, did this not... It didn't move into position properly. Hold on a minute. Oh, you know what happened? This is the part that sucks. Is if I want to make this part, and I want everything to be in position, I've gone to this drawing, and this drawing exists at a time before I rearranged all of this stuff into the proper position. So when I go into the drawing, this is now moved back a little bit, I think my parts should be closer forward. But this base drawing just, yeah, it exists at a point in the timeline. Yeah, see, it's not gotten my capture positions until later on. So I could potentially, well, aside from the extrusions, I guess I could take the capture position, try to move it earlier, but then the other capture positions are going to interfere with it. I don't know. It's pretty ridiculous, right? I know, meat world is annoying. I could start the design over. I don't want to do that, though, because I've got a lot of other design stuff on it. So yeah, what circle am I using in order to extrude that inside piece? Well, it's not that one. This is the wrong drawing. So yeah, finish the sketch without altering anything. Oh, it broke it. What the... Oh, wow. It totally broke the extrusion. That's neat. I can Control Z my way back. Oh, no, it didn't break it. It's just because I did the visibility settings. That's right. Yeah, there we go. Yeah, I know. Those extrudes are angry at me because they don't exist anymore. Delete. Oof. Wow, okay. There. Okay, so that's gone away. My chamfer, unfortunately, suffered from that. It was an unfortunate casualty. I can always get that back. Get the screw out of there. Turn that 90 degrees. Move it out. Okay. All right. Well, that's easier for me to work with anyway, because I need to basically project the motor shaft onto this thing. The problem is the capture positions aren't going to move in the timeline so easily. So if I move that motor back, I may have to grab the extrusions that I did in order to build this and move them. But if I move them in time, everything's going to go nuts. Yep, building the car in 3D in order to figure out where stuff interferes. Like, you know, what kind of space I have, where I can put things, where it interferes. I took components from GrabCAD, and then I made everything else that I didn't have, including a battery. Which, by the way, in order to make it look like shrink wrap, all I did was put an oval on the face and then extrude it in. That's all I did. Just put an oval on the face and extrude it inwards, and it looks like a shrink wrapped battery. You can add wires to stuff too by extruding along a path, but I didn't feel like doing a 3D path for the wiring. So, but yeah, that's, hey, give it the, what is it, Trinity or whatever, blue. You can even put a label on it if you want, but I didn't do that. So that's it. And then it was what is it, opaque gloss blue plastic, and then gloss gray for the inside. That's it. I tried to look up how to make something that looks like shrink wrap in Fusion, and Fusion has an operation called shrink wrap, so it confused everything. Okay, so we got rid of the erroneous extrusions. The problem working in the timeline like this is I have to figure out where exactly everything is. I think the extrusion for the hole is based on the base plate. So if I go to the first drawing, everything's moved again. I made that 2 millimeters. I'm gonna make it 1.8. And then none of my lines have moved or anything. So I can finish that sketch and everything will come back together. All right. So do I need the top sketch? I don't think I do. Wait, how come it still shows all the features in the sketch? Hey, they're still kind of visible. Like I can see them. That's really weird. That's really, really weird. I know I made the sketch on the face, but look at that. See, they're still there. They're like ghosts. No, I'm not a mechanical engineer. I'm an electrical engineer. That's why this is a discovery. My foot is completely asleep. Hold on, I'm gonna stand up for a minute. Everybody stretch your legs, by the way. I'm an electrical engineer, so this stuff is all new to me. The entire reason for all of this 3D modeling, in order to create an entire chassis that already exists, instead of making my own original thing, is because I really want to, what do you call it? Put electronics in here. Goldfish donation. What, was there a donation? Did it not show up? What does Streamlabs say? Streamlabs is a blank page. Cool. Yeah, look at that. Junkyardtuning donated $50. Holy shit. Dude, thank you so much. Sorry, yeah, thank you, Dewey, for reminding me of that. Streamlabs was a blank page, so I didn't see anything. $50. Don't feed Big Papa Amazon. Consider this my sub. Thanks for the info and the example of ChipQuick. Save me money and time as well as everything else. Dude, absolutely. Absolutely, man. I'm happy to help. Celia Russell gifting a sub to Leb TV Live. Hey, we got Leb on the board again. Thank you, Celia. Yeah, ChipQuick is such a great thing. It has a very specific purpose, but when you get something that needs ChipQuick specifically, man, is it a silver bullet. It just solves your problems. But Junkyardtuning, thank you so much for the generosity. I really appreciate it, man. That is a big donation. That's a big boy donation. We're waiting for Leb TV Live to go into the board. Any second now. Oh, there he goes. Ba-bam! God, we have so many little, like, fiddly things to do. Usually doing the little fiddly things is, like, where Fusion is pretty good. It kind of feels like I maybe need to start that part over. So that... No, because then I got to redo all the drawings. Yeah, the work that I did in figuring out the dimensions of the sketch, I want to preserve, but the timeline is a mess. It's a complete mess. It might help in the future to try to organize it a little better, or to make sub-assembly drawings that I can then assemble into the main thing. Because if I had a sub-assembly of that part, then I could re-extrude it and recreate it and then reposition it in the drawing. That might be the way to go in the future, but you never know when you're going to need to do that. You never really know, right? But like when I try to fit a body to this thing, I'll probably have to save off a version. Like, hey, this is the completed version number. Leb TV Live! You are destroying 3mares in a very Mario way. Over on the far edge of the board. AliExpress recommended me a BB gun because I bought an LCD module. Well, they know how you're supposed to dispose of it. This is a mechanical engineering problem, but I'm an electrical engineer, so I'm basically overqualified. Hey man, a lot of the stuff with springs and masses and oscillations directly translate to electrical engineering. It's kind of crazy. With RLC circuits, you basically do RLC circuits in mechanical engineering, which is weird. Yeah, he got destroyed. Absolutely obliterated 3mares. He was like, watch me destroy 3mares. And he was like laughing. Oh man, it was crazy. Okay, so yeah, we so many stupid little things that I have to correct here. So many. And we still have the mystery of the gap. This is a mystery. Why is there such a large gap right here? We're viewing at the very end of our timeline. Everything is put into position properly. The distance here to here is correct. The width of this is correct. Trinova Labs, hey, thank you for subbing. Always enjoy your streams. Yeah, it's something to pass the time while waiting for your CAD program to unfreeze itself, right? Sorry, I'm so sorry to hear that. You're just waiting. Oh my God. You know what? Control S. Yes. I'm gonna cough. It might be a good idea for me to like do a milestone. When you do a milestone, it locks all of the stuff down. So, Metrolux, thank you for following. All right, let's put Trinova Labs up on the board. Thank you so much for the sub. You guys are very generous. Very generous. Remember when Twitch was like, hey, you can support the content creators you like without ads? I remember. Then the executives came. More ways than one. Bazing! All right. Trinova Labs going up on the board. Going... Why? All the way over here. It's so far, and then I can't get the tripod over here. Trinova Labs. Thank you so much for the sub. Hereby Panic at the Disconnect. Subwolf plays games. Everybody's over there. All right. It's just that I have Burn the Subs 3 parts sitting in the corner of that table, and so it's hard for me to get the tripod over there. And people who watch the stream seem to think that every problem needs to be fixed. I don't understand why this gap exists here. Right? Board's still returning home. Because, like, I measured the part. I measured it. The part is precisely 4.17 millimeters thick. If I measure it here, from this line to this line, 4.2. So the physical part is actually a little bit more narrow after 3D printing, probably because it melted down a little bit. But considering how I have it indexed on this thing, that should be a gap there. But there's no gap. What's going on? Is it a compound of a bunch of different other measurements? Because I need to know this. I need to make sure that this is not the case in the regular thing. I need to make sure that when all is said and done, all these distances aren't different from one another. Measure this again. I'm going to measure the part again. 2.5. Okay, that's that thickness, 2.5. Measure it from here to here. It's not measuring the right thing. Why does it keep wanting me to lock in the position again? It's going to start to, the drawing's going to start to get very convoluted. 2.5, right? 2.5. 2.5. This distance to this, 0.725. It's almost a millimeter. But I don't have almost a millimeter when this is so relaxing. I'm like, you son of a bitch part, what are you doing to me? Yeah, like yelling at everything. That's almost a millimeter, and I definitely don't have that here. Unless this like pushed, no, I definitely don't have that. Where is that space going? Yeah, let me check over a couple things here. Now, when we went back to the sketch, that was out of alignment because it was going back in the timeline, back to where the sketch was created. And when I made the original sketch, I hadn't moved all those holes yet. So that's all aligned properly, and we've measured and redouble measured this distance to the end. What else affects it? The whole distance from the edge. But we measured from this hole to the edge, I got the exact number. There's nothing else to it. Every single index that I try to apply to this thing is correct. And yet, the numbers don't add up. That's what I'm talking about with compounded issues. That face to this face, butt face, 24 millimeters. I'm getting, well, 24 and a half. We got the problem. 24 and a half. Well, then, on to the differential housing. Every little mistake is sacred. Differential housing time. This is one of the more annoying parts. You want to see how this frickin' thing went together? Here's the convoluted process that resulted in that thing. Complicated drawing, extrude, complicated extrude the top, make a drawing for the top piece, extrude, cut that out, extrude that, make a drawing on the side, cut that away, make that circular, front piece, do that, do the extrusion, make the sides holes, do that, do the extrusion through the center thing and the opening, then extrude those into the round, the chamfer, and then soften that up, and it's fine. This part sucks. There's so much effort. This thing took so fucking long to build. I did a lot of measuring for this thing. Where's the error? I don't know. I don't know where the error is. 3 millimeters from this front piece to this edge. This to that. 3 millimeter. God damn it. So that's not where the 0.5 is. Looks like the angry chip. God damn. So 0.5 millimeter from, so this measurement, inspect, from here to the very front, 24. I've got 24 and a half. Uh-oh, spaghetti-o, because if I just give it that extra millimeter, everything is going to change. Everything's going to change. Because I can't give it the extra half back here. That'll affect the spacing of everything. Oh my god. This is a nightmare. This is a nightmare. This is my nightmare. $21 from case to case. $21.4. Yeah, this drawing has many things on it, and many things are based on many locations, including an offset of 10 from the front to that center. And if I make that 21.5, oh boy. Well, this is gonna blow everything up. Everything's gonna explode. Should we just do it and see what happens? Let's see what happens. By the way, this is not the only drawing. This is one of a couple of drawings. Sketch 2 is the top features, which are based on distance from the front, centering, a lot of stuff. Yeah. That's creating the ears on the ends. and then I've got a side sketch that does those parts. This is why I think that this piece was a bunch of locations of stuff, like where the A-arms meet, where the tie rod tops meet, where the transmission is, where the differential is rather, where the dog bone, the axle mounts are, where the powertrain comes in the front. I think they basically just drew boxes around all those components and then came out with this thing. But I'm reverse engineering it from another perspective, so I have to live in a weird state. So this needs to be 0.5 millimeter longer without any of the holes moving. CV Demonstrary. Thank you for following. I appreciate that. Does that mean the holes don't move, but the holes are centered? Oh, you know what? Oh man, I need that to move forward. I need that line to move forward, not this, not this. Ugh. Oh my God. Okay. All right, I think I could do this. These are based on this distance though. Which that is based on this. If this moves forward, then I need these to be 10.255. Oh my God. Can I press pull the faces? No. The whole thing, all that stuff, the bearing location, that all needs to move forward by 0.5. I'm just going to do it and see what happens. Let me look at that original sketch again and see what's going to move. What is this size based on? Center position. Center of the drawing. So then that pushes out and the other one pushes out. This piece remains 10 millimeters because I measured 17.5 here, and then this distance to this distance, and then I figured out that that was a 10. If that stays in place, and most of the stuff was based on that, we should be Gucci. I hope. This is, so because this is reverse engineering. Oh, Masters 1245, thank you for following. Because of the way this is constructed, basically I have to think about it as what are my reference points? What are my indexes? What's indexing the entire drawing here? For me, it's the location of this top piece here and my virtual center, because the A-arms are off by a little bit, and then the center of the actual enclosure that makes up the whole thing. So I make that a little larger. Ooh, wait a minute. No, it's just that one face needs to extend. What in the fuck? Hold on. I've got some bad measurements here, and this is the differential housing for a wltoys W989 kit. It's a little tiny RC car. 1/28 scale RC car, and some of my measurements have some inaccuracies in them, and so we're going back through. The lesson today is going back through Fusion 360 in order to correct your past mistakes. What bugs me is that if I move this face forward by a half, this hole still aligns up here. What about these? Because this distance we measured very carefully. We measured this distance to this plate right here. And we've got that pretty accurately. Oh my God, my brain hurts, guys. Chat, my brain is killing me now. My brain hurts at this. This distance and this distance would mean that the other stuff that we did to the plate is wrong. And it's even further than we thought. We got 5.55 between those, and when I measure them normally, we're in perspective. Hey, ISO, how's it going? Long time no see. ISO's saying that he's doing photography on the handle ISO Optilator. Just a way to further bully you for saying a word wrong once. Yeah, I once said ISO Optilator instead of Optilator instead of Opto Isolator, and ISO Optilator ran with it. Yeah, Fusion is a very good-looking program. But this model has been designed by a child, and so I'm gonna cry. I'm gonna cry. I need everything to move forward 0.5 millimeter, but if I move the holes forward 0.5 millimeter, they're not gonna meet up properly because we measured this pretty carefully. And if I move this 0.5 millimeter, these holes are gonna move. And this distance is gonna move. Oh my God. My drivetrain is gonna move. Everything's gonna fuck up. I need to correct it. It's a big error. 0.5 millimeter is not acceptable. I need this to be represented properly because I'm designing a part right there that's associated with all this stuff. So follow me on Instagram. There's zero electronics content. I'm gonna let you get away with that because you took a word that I said and made your whole account around it. What is the problem here? I think what needs to happen is the outer walls need to expand, because if you look at my model, check this out. If you look at my model, you can see this bulgy right here, right? But if you look at the real thing, no bulge. So that stands to reason that I should be able to expand that and things move forward a little bit, but without altering, for instance, this distance. Well, actually, that would change. Why did my phone just make a bunch of noise? This is a weird one. Oh, a friend asking me if I want to do tablet repair. And a kid probably dropped the tablet. But is there a side bulge? There is. There's a bit of a side bulge. And there is a bit that kind of goes over here. 400 bitums. Hey, thank you, man. It's almost a sub. Really like your content, your drained look. Cool. Also, I love everyone in chat, and I of course love the streamer himself. That's mostly positive. My drained look. All right. Well, I really appreciate it, Masters. Thank you for the bits, man. Hashtag drained. That's how I'm feeling right now. All right. 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 Here's what's going to happen. I'm going to make the correction. That's what I mean. It's all right, man. Here's what I'm going to do. I'm going to expand this 0.5 millimeter. I'm going to see what kind of hell breaks loose as a result. Save a copy. I can Control-Z it. The design? Yeah, man, it's cool. Thank you. No, hey, I appreciate it. It's a fun bit to do. I'm going to hit Control-S a couple times. Maybe lock the position in first. Go back to the diff housing. It's not like I can't Control-Z it, but... Oh, boy. Wait. Yeah, because I extruded that 3. Yeah, 21.5. Oh, the A-arm position moved. Think about that a little bit. Hold on. I think I measured it against the front. So if I did it from here to the front-ish. Man, this is tough. I have to undo the process that I use to figure out where stuff goes in this model. So So 21.5, and then that arm goes up to numbers that I don't want to deal with right now, but I'm going to have to. So I did straight 10 millimeter to get to the middle here. That is the middle of this, which is 6. So it's 13 millimeter. Thanks a bunch, ISO. Yeah, I know. What? Oh, ISO optolator. Oh, that's what you're saying. I thought you were saying like ISO standards. ISO optolator gifted a sub to Chester Willard. Let's put that up on the board. Sorry, I'm goldfishing right now because the weight of my mistake is starting to come out. This is exactly what I mean for today's content, guys, is that process of ironing out compound mistakes in a design. That's a beast of a design. Oh, of course. Why is the board leaning so far to this edge today? Really? Really, you're gonna do me like this again? God damn. All the way by Herman 122. Chester Willard, gifted by ISO Optolator. Thank you so much. Thanks for not banning me for shameless self-promotion. Like I said, you're on thin ice. Masters, thank you for the 100 bits. Do you program? Yeah, I do. That I do. We don't have anything to program right now. We did a lot of programming when I did the motor controller. You almost blasted NASA. NASA's got a nice little radius around it. Oh, the top of my chair is falling off. That's nice. All right, yeah. So I'm moderately pissed off at the moment. I'm moderately pissed off because that little change changed a lot of different stuff, and I saw this move, which means that things are all over the place now. That being 10 millimeters might still be kosher because this is based on a center position of that of the arms. So the widths are all the same and stuff like that, but that extra half has kind of moved things around, and I need to figure out how they've all shuffled. I need to verify that all the little shuffling is okay. Yeah, when you do a center square, it adds construction lines, the crossing construction lines. That's why there's so many of them in this particular drawing. That's fine because I wanted stuff to be based on centers because that seemed to be how it was designed. So yeah, it makes for a very busy drawing. I could have done different drawings for different facets of this, but that's just how I did this. Okay, so 10 millimeter to the center of that. Now, does that seem reasonable? From what end? I think it's the front end, so I gotta go from here. Yeah, because it should be 13 to the edge, and it's hard for me to measure that. I think that's still in the right spot. I don't know, though. See, this is going to change so much. It's like I can't make the 0.5 millimeter only go out the front side. I don't think that's how that works. I don't know. Let's just try to finish the sketch and see what it does. It blew it all up. It destroyed my whole drawing. Look at what it did to my boy. Oh my God. It completely obliterated it. I can go back through and I can correct all that stuff. Or I can Control Z and get rid of the 0.5 millimeter. See, what it did is it covered over some of these surfaces. And so Fusion went, I don't know what's happening. Just everything's broken. And so it then breaks. Yeah. So what are my options here? I mean, I could press pull, but that's gonna, if I'm confident about this location, Jesus Christ. Locations am I confident about though? Because I can press pull that, that little distance here and here, but then the thicknesses of the inner walls and stuff is going to change. Oh my God. 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 All right. We can do this though. We can do this. I can get this. I mean, just for shits and giggles. Yeah, 0.5 breaks it. I mean, this might work, but then some of my distances change. What happened here? That's not supposed to be that thick. Why didn't that allow me to do anything? Do something. No, nothing. I don't think I like whatever I just did there. I don't think I like it. Because it didn't really move. It made this thicker without moving the bearing race forward, so. I mean, so if I remember all the numbers, I guess I can redo a lot of this stuff. I just need to make sure that the distances are still accurate. So if I go from the top edge over to there, this may be a little bit more work than I wanted to do on stream. Like there to there is 5.6. So this face... I love it when it doesn't tell me the number. Oh, because it thought I clicked over there? What do you... Okay, okay, Fusion is very confused right now. Here to here. 5. Uh-oh. Uh-oh. I'm gonna cough. I just measured 5.6 for that. That's not good. Do you like racing games, racing simulators? Yeah, man. We created a steering wheel with a 2 horsepower servo motor on it. It's like a direct drive steering wheel, basically, out of an industrial Mitsubishi servo motor using Granite Devices controllers. I got to bring that out again. We'll have to do another day of racing games with it. But yeah, it's like a really heavy amount of force feedback. You just add a tangent constraint to the circle on the wall. Might break it too. Yeah, I think anything that I do at this point might have repercussions. I'm probably gonna have to rebuild this part. I have a lot of the limb lengthener. It's more like the limb twister. Yeah, 5mm is wrong. That is wrong. So this part is the one that's to fault here. Yeah, I'm getting 5.2-ish to there. What about from the front face to the front one of those things? Hold on. This is an incredibly, not incredibly accurate. 4.6 from here to here. Oops, that's not. Here to here. 4.6 becomes 5. It looks like that should all slide forward then, which is what it would do. Diff Housing Speedrun Design Challenge. All right, so let me put the 2.5 back in and let's see what happens. Means we're gonna have to move around a bunch of components, but we'll survive somehow. Okay, so back to sketch 1. 21.5. That's going to take me a minute to unpack. Hold on. Hemiturcan. Hemiturcano. I mean, I see official. The Metercan official? Meter can. It's the meter can. I'm reading some mez here. Official. Thank you for following. Oh man. Okay. So what happened was that line now moves out from this circle. I don't know if this still recognizes as its own. It does. Good. All right. But what that means is that everything else is gonna like the interfaces, like extrusion areas that I've selected are moved now. So that's going to affect this. So I got to go through step by step now, because when I finish sketch, it comes out with this utter atrocity. Okay. So, first error. Well, first of all, this extrusion is probably my first error. I'll go all the way back on the timeline. Let's go from here. Yeah. Gee, this looks just like what I wanted to have done, huh? All right, buddy. What are you trying to accomplish here? So that, this. As I go through this, it'll hopefully have somewhat of a healing effect on the drawing. Right. I'm gonna build this back up into one big solid. Unfortunately, these designs have a lot of different holes in them now. Actually, that one did not get extruded with that. That one does. Oh, man. Now, I guess technically I should take all of this because I cut it later, so. I gotta tell the software what I did last time. What's that doing there? The hell is that? Come back here. You. Fusion is like going crazy right now trying to figure out what the hell I want. Oh, I think maybe some of these boxes moved to where they shouldn't have moved. That's why there's little gaps in them like that. What is that? Oh, Lord. This is getting a little crazy here. Like, how is that not highlighted and yet it's extruding? There's some weird definitions going on here. Yep, another weird mark. No, no, no. There's like these tiny, oh my God, this is obnoxious. It's like a hairline. Shouldn't have been like this. Why is it like this? Some of the lines moved and they shouldn't have. Like this little hairline right there. Now, part of the defining principle of Fusion is that you are able to go back in the timeline. Well, right now, what I'm trying to do is fix stuff that's weird in the timeline, and I think maybe some of this stuff is not attached as it should be, because that center bar should be attached to there. Unless something from another drawing is like bleeding through, but they're not here on the timeline. They were like, these weird shapes that are like showing up in certain areas are not defined in others. And there's stuff that I added to the drawing like later on that wasn't defined as well, so. This one's really bugging me though, because I can't select it. Oops, I hit escape and then it undid all of that. Well, okay, everything's frozen. Nope, no it's not. Look at this modern art. All right, what's going on, Sketch 1? You want to talk about it? Yeah, here we go. What's going on over here? Yeah, look at you, you little bastard. Why don't you lock yourself in right there? Solve all of my problems. That's what it was hiding. Stuff that I thought was snapped, but wasn't. All right, that might help. Everything is still going to be broken, so I'm going to go back to my first extrusion. Now I got to redefine all this stuff. Look at what it did. It did like, okay, so in this extrusion, I chose the broad area of the thing to extrude, And because I've barely tweaked that, it suddenly decides that I wanted the center of this hole and then the outside of that one. I don't know, man. Looking like it might be a lost cause. No, 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 no. We still got it. Still got it. I'm gonna get it. I just will need to reinvent some stuff, I think. Man, stupid complicated drawing. The problem is, like, I don't know where to base a lot of the numbers on. And also, why did that... What was telling it that this was something that I wanted to have happen? Where's that line coming from? Is that coming from a sketch that doesn't exist? Isn't that weird? Might have to define coincident constraints on those points lines instead of just snapping them. I don't know. Yeah, I don't know. Well, I can still rescue this. If this one is the bottom section, then I actually don't want... I want the inner hole, not the outer one. Well, that might mess things up later on. We'll get it. It seems like it's somehow defining these areas based on stuff that, like, doesn't exist in this drawing. At times. Like, where's that line coming from? Very strange. I should maybe try to, I could re-extrude all the parts. Of course, that means that the parts that are based on, the sketches that are based on faces, they might be okay. It's not like selecting the area, it's selecting something else. Very weird. Very weird. I'm getting very frustrated, but that's because we are doing part surgery. Part surgery is a complicated affair. I just needed a 0.5 millimeter that I should have put in the drawing ages ago, and it ruins the rest of the entire thing. Isn't that fun? Fun, 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 fun. All right, so there's that. What does that do for the rest of my timeline? Well, it fixes a lot of stuff. Whoops-a-daisy. Also doesn't fix a lot of stuff. Back to the first extrusion. I do not want this corner. Anything else? What else? So far we're doing pretty good. Oh, we missed one of these. I could have sworn I selected the right thing on both of those, but all right. Look okay. We're still missing one extrusion. Oh god, that one broke too. All right. Dr. Plugger. Something of the prime. 25 months. 4-month streak. Hell yeah, Dr. Plugger. Let's put you up on the board. This is some part surgery here. I mean, I'm trying to turn this thing out of the, make it stop looking like modern art, you know? Dr. Plugger going up on the board. Thank you so much for subbing. I really appreciate that, man. Appreciate it, appreciate it. This is, I can't believe the cascade of error that I've discovered here, just because I didn't take a measurement properly. I said, oh, that's close enough. That'll be this number. And then it affects everything, and I have to check everything again. Just the foundations. That's what it did. It just shook the foundations of the whole thing. This isn't a scenario that would help with triple checking the measurements, though. Dr. Plugger, welcome to the board. you saw how far I got while checking everything over many, many different times. I got really far into this until discovering that something was just barely off. So this is just the type of stuff that you got to deal with. That's all. There's no strong lesson here. This isn't a, well, you measure once, cut twice, and you 2 chickens in the bag is worth 4 in the drum. That's not what this is. This is just what you got to deal with when doing this kind of stuff. That is so cool. Hey, thanks, man. I made it myself. What's happening here? What the fuck? Wait. What the fuck? What the fuck happened? Wait. What the why did it rotate? Yes, yes. Okay. What? What the fuck? What it? Why would the side wall change the location of this circle? The only real lesson is you try to constrain drawings so that changing them doesn't destroy them. That shit happens anyway. Yeah, that is a good lesson. I mean, I thought I projected this face and then, oh, why did you change to there? Absolutely, I did not say to do that. That is absolutely not what I said to do. What's up, Mr. Mig? This is not the corner that I wanted. I definitely locked it to there. But then I guess that changed or some shit. Why is that like that? Oh my God. Am I gonna have to redo this whole drawing? This whole drawing is starting to smell a little funky. Looks like I lost a projection face on the drawing. I don't know what all this stuff is. Why that's like... What is that constraint? And this is supposed to be centered. Why can't you move? What's locking you in? This? Is it this? Oh, there's one of these insidious little projecting lines that... Okay, there we go. Sometimes, I think Fusion likes to click multiple times for stuff. Oh, and that should be a construction line. Okay, that's corrected now. Even though that is not locked in. That should be locked to one of the faces, I believe. But for some reason I don't know, it just seems to be all right where it is, so... Oh, and then there has to be... I need to draw a square that's not construction line from here to here, so that I have something to extrude. Oh, there we go. You're the problem. And this needs to extrude to a face. Oh my God. Okay, you get out of here. This is broken. This is very broken. Okay. The problem was the lines that I projected changed, and so that blew it up. Yeah, this is parts for an RC car. I made a slight adjustment, and it exploded. Yeah, a lot of the stuff that I put together kind of blew up, but we're working on fixing it. We should be able to get it done. You just got to go through step by step and sort of refine things out. Okay, all right. Whatever the fuck that was. Where did that drawing go? There's that. And then what are we extruding? No, not that. And not... Why did it decide that I, in all of its infinite wisdom, that I would love to extrude not only the connecting piece... Oh, I see. I need that little line on that there. Aha. And then I need a little line coming up from there so I don't knock that out completely. We'll go back to the sketch. I need a little connecting line Oh, I have one there. That's the other side. Right, I need one here and here. Those are the things that broke the drawing, basically. Oh, look, it looks like there was something. Okay, so take a regular line here, straight across over to there. Regular line right over to there. Okay, I can rebuild all that stuff. Don't know what it is, but I'm sure you'll get it. Thank you. Finish the sketch. Haha, look, it's gone. I know you can't find your fillets. It's because I need to fix this. Because you just made all these assumptions, AutoCAD. All these assumptions that I wanted to cut stuff, do this, do that. Now, it's trying to like resolve all this stuff that's broken. So it's just like, I can't think of it fast enough. All right, there we go. Okay. Yes, yes. Okay, so that should be fixed. What are you not finding? Well, there's still surfaces that are missing, so we need to fix that now. So, when did I extrude the top piece? That cut, those pieces, this thing. Then I turned and I worked on the top piece. So that one is the initial layer. Nope, nope, nope. That assumes that that's already there. Is that there? Somewhat. Somewhat. Nope, that's not what I wanted. That's the extrusion for the very top. Oh, it smells like cut grass out there. I wonder what they're doing. No, no. Oh, God, what step is it? When did I do it? There. You, what are you doing? Yeah, same thing. It's the, selecting 10,000 different structures on the bottom here. Yeah, this houses the differential and the shock towers mount to it, and it has the tie rods. It's a pretty comprehensive part. I mean, it seems maybe like they started with the entire drivetrain, and then they kind of like invented this around it. God, I'm gonna have to select all these parts of that. Why is there so much Z fighting going on though? What's up with all the Z fighting? Jeez. All right. Well, I'll have to investigate that, but for now I just need to finish this. Selecting all these various disparaging boxes. And for some reason, oh God, the software is really confused about what I'm clicking on. Oh, great. It's great. This is great. Screwed it up. I hit escape and it got me out of that step. I need to not hit escape. Which one was it? Which one was it? I can't find it anymore. It was over here. There it is. I gotta look for the one that just highlights that one pillar. Just the one. Oh my God, there are people walking around by the window outside. Isn't that wonderful? Move you guys over to here until people don't show up on camera. While I try to find that pillar, where is that extrusion? I wish I could mark out this stuff more logically. There's probably a way that I could put stuff in folders, like in the timeline, but for now I'm just sitting here highlighting each individual extrusion to try to find where I actually did the initial steps of the top layer. Oh my God, I can't find it. I might have to rage quit. I don't think I'm gonna rage quit. I think I'll be able to fix this. It's just changing that one drawing changed like everything, and it changed a bunch of projections, and everything just went nuts. So it's just a matter of finding those steps where things went a little haywire and then correcting. See, that's the initial extrusion into this. Where is this? Oh yeah, I can click on it and it highlights the step. I should have remembered that. Okay, there. Okay, so now I've got to define all of the stuff that surrounds that. So I'm going to unview the solids so that they're not in the way. Now I can go through and highlight all the stuff that I want this thing to extrude, which is basically just making it into a giant block. That's the initial step. The strange thing is, like, what did I just click? I didn't want that, whatever that was. I only want to select the drawing, but for some reason there's like hidden structures that Fusion is like, hey, do you want to click on maybe this solid face on this part of the drawing? Like, no, see, it did it right there. I did not want whatever that was. Whatever you selected, I don't want. And yet it's here, it's part of the drawing, but I can't unview it. It's still there, even though I have made it invisible in the drawing. That is a bug. That's a bug, and I don't appreciate it at all. I'm just gonna try to select the right stuff. There, it did it again. And, you know, you'll probably report the bug and they'll go, well, you're supposed to wait until the solid highlights. And then everybody goes, Fusion, your team is dumb and they need to learn how real people use CAD. And then eventually they'll fix it. But that's how I was getting all those weird little shapes, was by not waiting until it highlighted the entire block. This should definitely be broken up into multiples. Yeah. Multiples with projections would probably have been the way to go. I actually did break it up into multiples in order to clean it up more. Because you know, I'm thinking of this part I feel like was designed differently from everything else. See, there it goes again. I didn't want that. Damn it. I'm trying not to select other faces in order to create this. I gotta start over. Yeah, there's always a next time, but who knows if I'll design it correctly next time, right? If I'll remember to do this next time. I think I need to draw the blinds because I think people are too dumb to stay out of view. Okay, remember to highlight it. I don't want to ruin this. Because the last thing that I want to do is select a face to extrude from, because that could pull up other weird errors later on down the line. It's like the difference of 1 pixel. I need to be pixel perfect, speed run, fix differential casing. As I move the mouse, you can see it. The flashing is it highlighting various other structures. This is not a good way to work. Not a good way for your software to work. I literally unviewed those pieces so that they wouldn't do this. Here I am. Now this one is the outer hole because it's the top piece. Careful. Careful. Deliberate strokes. Be very careful. Be very, very careful. Okay. Whew. This is like 10,000 different structures. These didn't all come at first. This is my designing and redesigning what I was doing in this drawing. Like I'd measure something and then redo it and then, you know, have to do it a couple more times and then add things to a drawing from earlier. I just fucked up. I'm gonna leave that. There's nothing I can do about that. I can't unselect whatever that was. What did I end up selecting? Ugh. All right. Whatever. Can't live in the past. Wait. What is... Oh, yeah, that's the output. Okay. Careful. Oh, come on, man. There we go. Jeez. This is a major pain in my ass. Did we do it? I think we did it. Whole structure's there. There's no weird lines anywhere on it. Okay. All right. Looks all right. It's looking a lot like our solid. We're still missing a couple fillets. I don't know where those went. I think it's maybe the ones that go under here. It is. Okay. Two edges, tangent, G1. Okay, so that's these. I never learned how to add fillets to this though. Well, at least I can double them up. Are you not letting me select a line? What's going on? I guess I'll just plus you and you. You're gonna be 1 millimeter. I don't like how it does that. And then we're still missing a couple. Those are these. Plus, and then we'll add no. This one, no. What did I just select? Apparently nothing. This line, yeah, hi, I want this line here. It's not letting me do it. I admire your dedication to try and fix this timeline. Hey, I'm getting there. Why can't I? It won't let me select that line. It's right there. Oh, oh yeah, okay, sorry. Yeah, plus. You're right. You're right. 2.25. Jeez. To think I could just play games on Twitch. Just play games, and games have like plot and structure, and they're made to like be enjoyed. They're made so that the player can get like positive feedback and stuff instead of sitting here and harassing myself. Now, if I move the timeline around, I could fix this area right here. This has bugged me. This place right here. This is like the Dark Souls of CAD. I could fix that top area. What they did is they hollowed it out later on down the line. Sorry, I'm trying to show you guys it, and I keep dropping this all over the room. What's up, old man, Shorty? Shorty, look, it's you, but from the future. Apparently, you started streaming and you partnered with the platform. I've got a previous version of you as a regular on this channel, but he's not as tall and he's not as sociable. So you can see the difference between these two is that they probably hollowed it out afterwards, later on down the line. We aren't supposed to cross paths. Ah, the continuum. Ah! No, right now this is a model of an existing component that I'm showing right now, and it looks like before they created the hollow for the differential, they made this chamfer, and that gave them more material to create this rounded feature. I don't care about the differential, I just care about the outer dimensions. So I didn't add that feature there, and it turns out that kept me from doing a larger chamfer on the inside. So a little eye into how the order of operations affects stuff like this. I think that's kind of interesting. And I can correct that. I can move stuff around on the timeline to fix that. Anti-graphics, thank you for following. Yes, so this is an existing part, and for some reason it lost the appearance command. There are no more errors on the timeline. Let's just do a quick look around. Quick tour of the part. All the features that I originally put in it are still in it. Oh, it's not called the right, it lost its name. WL_diff top. And then I'm going to go into appearance. And I'm going to take the same black plastic and pop it on there. All right, close. Okay, so I think all the features that I want to have on this are on this. All of my holes are located in the right spot. That's always important. All of my openings are somewhat represented there. Excuse me, hold on. See, what this is hold on. Oh, all this talking, my throat's starting to dry out. So this part is part of the wltoys 989 all-wheel drive Mini Z car. And I am 3D modeling the thing comprehensively, in part because I'm stupid. But also because I want to have all this stuff in the right spot so that I can design a body around it, and then also 3D print parts so that I can use different things. I'm using a different servo. That servo is actually a pretty nice servo. I could also use the other size of that servo if I want to, but I've already bought too many of those. So different servo, different motor, 1-cell battery pack. And then once I've done all that, I can design a circuit board that's going to fit in this space that will control it. So the circuit board is really what this is kind of working. The circuit board and the body that goes around the whole thing. The body that goes around the whole car and the location of this circuit board are the important facets of this design that I'm trying to get done. And that's the reason why I modeled so much of the outside of this car. See, originally I just had random parts like this piece right here that I originally designed on its own in order to mount a little top spring setup for the thing. But yeah, that's where this all came about. But yeah, this has been my weekend project. Has been fully designing this whole thing. Now here's the deal: I haven't saved yet. Chester Willard was about to have a baby because I didn't save. I'm gonna hit Control S on this. Let's verify some of the measurements. I'll do 2 of the face-to-faces and see if they're within tolerances. Oops. So inspect this face to this face. That distance is now 5 millimeters. I think that's what it was at before. Where's my piece of the I have like 7 different names for this part. 5 milliliters. 4.90. That's within spec. Check the other side. See, these aren't exactly designed as it was. One of these has a larger hole than the other because there's actually like a pin that fits through there. But anyway, inspect this to this. 5.5. 5.2. 5.3. Well, maybe that's off by a bit. Maybe that's off by just a little bit. 5.8. What the fuck is happening here? Oh, I think the face isn't exactly square. 5.3. I think it's good enough for me to poop on. And then let's do here to, let's do the body of that. So I'll do from there to here. 7 millimeters. Nice even number. That is from here to right there. off is the measurement that I got. Turn that back on. 8.6. Uh-oh. .6. We gotta move stuff. Stuff's gotta move. Oh wait, that was to the back face. Wait a minute. 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 From here to here. It's not 10 point. What in what world do you think I selected? Okay, so from here to here. 8.5. Okay, all right. It's correct. It's correct. It's correct. It's correct. I think we fixed it. I think we fixed the part. That took major surgery. I kind of wanted you guys to see that, though. I kind of wanted you guys to see major surgery on a part. When your part moves around and different lines no longer create the spaces that you defined in order to tell it what to extrude, Fusion throws a fit. But you can recover from it if you go through your drawing step by step and identify where the software had a brain fart. Whew, man. Precisely. Okay. Save. Here's the fun part. The dimensions of this part changed. I don't know where those pins are going to end up. Oh boy. Everything could be shit. Let us update everything. Oh boy, here we go. Update external references. I'm looking to see what moved. Yeah. A 1/4 of a millimeter in from the edges. Well, those are in the right spot, miraculously. What about you? Yeah, you're doing all right. Wait, that shouldn't go all the way up to the... Wait a minute. Wait a minute. What's going on here? That's the wrong hole. What happened? Something happened in here. Oh boy. Something is not right. Okay, there's still errors. There's still errors in the part. What is happening? Look at what's happening down there. Oh my god. Something horrible has occurred. We need to correct that. That should not be visible through the whole part. This one should, which it is, and it's perfectly fine. Oh, the split line is like way up there. Same thing here. How about up in front? Good. Good. Pins in the right spot. The only problem is this. And we measured this part like 1,000 times, and yet now our pins are off by a little bit again. I may need to remeasure where those ended up. Ugh. Crap. I may need to look at the holes in the transmission too, or sorry, in the housing. All right, so things got a little messed up with these holes because these are messed up holes. The one is 0.5 millimeter wider than the other one. The difference between them. So let's see here. If I go back to the extrusions, I don't want to. All the way back. All right, where are we making this part from? Here. Oh, well, that's a problem. What happened here? How did that happen, and why did it work? In the world? All right, so that is that inner one going all the way up and through. And actually, I think what I need to do is instead just make it solid. Oh, you know what? No. That should be... Should be the outer one, and then the inner one got its own extrusion operation. Hold on, I'm just gonna cancel that and then come back. Ugh, my hand's like falling asleep. Okay, so there's some confusing things about the way that I designed those holes, because I only discovered well after the fact that they were in fact spaced differently. So in order to get back what I had, see, these are in the correct location. Those should only go a certain distance, whereas the rest of them should go up through or down from. And that's only been referenced here. So is that an extrude as in a collision, or is that a cut operation? Where was that step? Why wasn't it highlighted here? Yeah. What is this one? New body. Okay, so that's the original creating that. I could extrude this. Uh-oh. OBS Studio just disconnected from the WebSocket. What happened? Why'd you do that? Huh. It says OBS disconnected, reconnecting, which probably means my Stream Deck no longer does focus properly. No, it still does. Weird. Setup. Lights toggle. No, that still works. Oh yeah, that's a different connection. Huh. All right, I guess I'm still okay. Strange. So what I'm trying to do is figure out how I put this friggin' thing together. I'm just trying to figure out like which lines I'm supposed to be, you know, selecting where. All right, guys. Should I have not cut on the original one and then come back and cut it later? Is there like a cut operation that I have here that I'm not? That would be the top pins, that piece there, that one. Oh god, there's so many more operations. Yeah, see right there. Okay, that's where I cut the top pieces, but it looks like it's from the wrong. Oh, because the other one didn't. Okay, so it bumped it down. Are those supposed to go down from the top? Somebody's having a fucking dance party over my head, and it's the most distracting thing I've ever experienced in my entire life. It's killing me right now. There's all that Z fighting on some of the surfaces too. That's really bugging me. No, it was disconnected from WebSockets, so I don't know what that entails. It's like the sound of somebody like taking slow footsteps with dress shoes. Right over my head. Just the worst. Just the worst. So when I initially extrude, I think what I need to do is just keep all. I think I need to split this out into different operations. I think that's what I'm going to do. So what I'll do is just take the. We'll do a couple different cut operations, right? I'll take out. On the initial extrusion, I will include all of the. Sorry, guys. I'm just trying to figure this out. On the initial extrude, I'm going to include the screw holes, irregardless of where they are. Yes, I did intentionally use that word. You gotta be careful when you go in and edit stuff like this, because it will interpret your combining of bodies in order to it'll if you have a join operation and something that is visible that shouldn't be, it will join those things, and so you'll ruin your part by just editing a step. Looks like I should have kept the front ones though. We'll keep the front ones then. Boop. Over to here. Boop. Okay. All right, so that one's still there. Those holes are still there. Ah, there we go. That's all it took. That was it. I shouldn't have selected the rear holes in the initial extrusion. You see, I rebuilt them. Now everything makes sense. All right, Control S. Click OK. The only thing that could potentially be off is where these pins are. Let's take a look at the top sketch and figure out where these pins are located. There's one thing after another, you know? Sketch number 2. Why are there 3 pieces here? Oh, weird. I'm not gonna question it. I'm not gonna question it. I'm just gonna do this. Okay. So our distance to these two things, I've got 6 millimeters, obviously 4 millimeters between them like that, but 6 millimeters between the, okay, 6 millimeters to that rear hole, and that's a 2 millimeter hole. So remeasure the pin on top. It's like I'm getting like 1.3, but it is 2. Yeah, 1.6. I'm calling that 2. And then that distance there is 7. So that would be 1 millimeter. That would make it 6. But it's clearly off. It's off by a little bit. If I were to interpret this pin as not being 2 millimeter wide, if it is in fact, I don't know, 1.8, 1.6, 1.8, and that distance, because I'm not necessarily measuring it correctly, something like, I'm getting like 6.75. Which actually getting 6.75 is almost exactly right, but I am working backwards from the numbers. I got a cough. God, I don't know why this cough has gotten worse. It ain't COVID. Probably because I'm talking. I'm talking. It's not COVID, don't worry. All right, 1. That's out of focus. That's out of focus. Sorry, that was a lot of work just then, so I'm mentally a little rough right now. You got Rona from a club sandwich? God damn, dude. I've managed to avoid it, and I plan on continuing that trend. So 1, 2, 3, 4, 5, and a half. It's more than 5.5. I don't know if it's quite 6. All right, time to get a straight edge over here. Let's get my right angle on this thing. Oh God, I dropped the D20 on the ground. What did I accidentally roll? It's all the way over here. Hold on, I gotta find it. Dropped the D20 and I rolled. A 16. Not bad, not bad, not bad. All right, rolling a 16. I assume everything is COVID now, even a sore ass. I know, right? All right, so straight edge. Up against what I'm measuring. Just get a thumb in there. I don't want stuff to interfere with the distances that I'm measuring. That's the problem. It's very difficult to get measuring stuff in here. Also, this view isn't straight up and down, so I just want to get it up against that edge. So there, 5.5. That's looking like 6 to me. But if that's 6, that means all of our other measurements are off. Ugh, God damn it. God fucking damn it. That really does, it looks like 6, right? It doesn't look like 6.25, which means everything moves again. See, if it were between the two marks, between the half and the hole, then it would be 0.25, but it's not. It really does look like 6, doesn't it? Yeah, it looks like 6. I can't argue with that. That's 6. which means that our top and our bottom plates are off. Or no, just the top. Because this isn't meeting up with that top bar. But we measured the top bar like 3 times. Oh my god, this is my worst nightmare. Perkele is right. Yeah, see, that lines up properly now. That's all well and good. The pin in the bottom lines up still. This distance might be off by a little bit. 5.3. It's a weird number, but it's probably about what I get. 5.24. Yeah, how's that? How about them apples? 5.24. This we know still lines up. And I know that the length of this whole rod is correct because I went over that 50 times. Let's take a look at where these holes are on the... I can't think of any other component that could be the problem. We pretty carefully measured this, though. That's the thing. $78.2. Maybe it's a little more than that. There to there. That's locked in at 5, but it's off by a little bit. 78.2. What am I basing those off of? I think they're mirrored in the middle, so I think I'd be moving both of them if I move them in. But I think they both need to move in, because we moved them both symmetrically. We did. So from this to this, it's off by 1/4. That's an interestingly round number. My holes need to move in by 1/4. Jeez. So the original measurement was 80 millimeters, and it still is. That's what bugs me. This is the part that really pisses me off, is that we measured exactly 80 millimeters on this thing. 80 millimeters from here to here. Look at that. That's like exactly 80 millimeters. 79.99, right? Like, that is a good number. That is a fortuitous number. I'm getting weird errors on the calipers. I saw something like E pop up. I mean, 79.75? Does that equate to the amount that we're talking about here? Ugh. Ugh. That's an ugly number, and I love that it was 80. 79.75. 77.9. It's such an ugly number. That'll probably still be off. I don't think that fixed it. Oh wait, I forgot to save. These are saved. God, what a pain in the ass this has been. This is just what you have to deal with if you do something like this. I kind of knew that I was getting into that. Checking, double checking, redouble checking, going back on the numbers, and having, you know, one thing that you were absolutely sure is right is actually off by 1/4. Erwin, thank you for following. This is like one of those things where, you know, you're continually questioning, where did I get this number from? What is this one doing? What's that one doing? See, this is still off. I didn't quite move the holes in enough. 0.25? I thought that's what I moved it in. 0.25. 1/4 of a millimeter off. Wait a minute. Now only this one lines up. What the fuck? Wait a minute. How does... Oh, damn it. The one by the switch. So this one needs to move 0.25, but then the other one needs to move 0.0125. This is it's all falling apart. All of my wonderful, even easy to interpret numbers are they're all breaking down. Where did this position come from? Our distance from center? Yeah, it's over here. 94.5 is the radius of the circle. But this needs to move in. And that's a 94. I don't know which 94 it is. It takes it out over to here. I wonder if these are, in fact, symmetrical, and yeah, it's starting to all fall apart, isn't it? This is just like an arbitrary measurement that I took to go from one hole to the other, because that was a index that I could get. Turns out they might actually be a little symmetrical. The reason for that weirdness is because and this goes back to the beginning of the stream. I discovered last night that these two parts, the part that fits and the part that slightly doesn't, are not built the same. In fact, one of them has the holes off by a little factor, and it caused all kinds of pain and heartache. Now I can redo the holes in this part. I can just delete them and then redefine them on different measures. But like if I put these end to end, like precisely, if I hold them right on top of one another, those holes do not meet up. These do. So, or wait, no, it's like this. It's like this. I was holding that off. I'm sorry. These meet up. These meet up for the ones that exist. These do not. So I've been trying to get it right. I've been trying to remodel the part so that it's correct. All right, so, and that's why it's so complicated and I'm having trouble with the numbers now. I originally figured out where these were and then I moved the other ones. So if this is 94.25, so those are in the correct position. It's just these that aren't. And so in order to move these, it's going to move those. This sucks. This sucks. So if I take this back to 80, and then I take this to, I don't know which one's the right one too. It's actually the, okay, it's this one actually. I need to move. If I take that back to 93. Oh no, 90, oops, that was the wrong number. Did it not change? I think it didn't change. Huh. 94. Whoa, I was thinking about it. Failed to solve. Why? Why would you fail to solve that? I might need to remake how these things are placed. Do we think they're symmetrical? I don't think they're symmetrical. If we look at this part, the distance to the edge here versus, yeah, the distance to the edge here is different. Oh wait, but that's on the bad part. They are symmetrical. Oh, see, there's the assumption that broke the whole thing. That's the assumption that broke the whole thing, was that they're not symmetrical. Turns out they are. Okay, so here's how we can do it. Here's how we can do it. Under that assumption, which changes everything, I can now get rid of all of the stuff that I put in. Goodbye, holes. You're dead. You're dead. You're dead. You're dead. You're dead. Try not to kill too much of it. Leave that there. You're dead. You're dead. You're dead. Go all the way to the other side. There's going to be some stuff left over that I'm going to have to kind of like root out. but dead, 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 dead. Then this one, what is that one? Is it just a line? That's just a line. That's defined by something else. Yeah, that's my outer edge line. And then, oh, you're dead. You're dead. What are you? Oh, you're dead. 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 Back over here. Whoops. When you drag and move something, terrible, awful, horrible things can happen. And right now, Fusion appears to be locking up as a result. Uh-oh. Oh, we're back. Okay. Okay, so I want to get rid of that line. There we go. The 77. Go. And then the 14 and the 7 are okay. And then that line is where we're going to base this thing on. So we're going to come from the center. Oh, wait, this one's still here. What are you still doing here? Uh-oh, I dragged something. What happened? Yeah, there's a bunch of garbage left over in the drawing that I need to get rid of now. What is that box? What is that defining? It's like this here. What is this doing? What is this doing here? Oh, that's this outer radius. Okay. Yeah, that's there, that's there. That's supposed to be there. This is the center of that? It's not. That's what this is. The 95. Is that the one that I don't need? Cleaning out this drawing is not a simple task. Tell you what. Yeah, that's the 95, so that goes away. It has to think for a while on that one. That one goes away, that one goes away. Oh, man, cleaning this thing out, right? I don't know if multiple drawings is the solution to this or what. These don't have a radius. They should. Yeah, it looks like I need to give them a thing again. They lost it somewhere along the way. All right, let's give that a thingy. So, rectangle, center, construction line, from the middle, out and around, till we get to here. And then give that a distance. I can select it, which doesn't look like I really can. Please allow me to do this distance. You just do, can I select the dot? There we go. All right. There. So that's locked down a little better. How about the horizontal distance? Is that defined by something? I think it's got. The outer radius is mostly so that I could just find, you know, the stuff. I have now frozen 2 CAD programs. Oh God, a Libre and FreeCAD. What are you doing? All right, so we're doing centered holes. I'm trying to figure out what the radius of them is. I know that they are 4 millimeters apart. All the holes are 4 millimeters apart. That's easy enough, right? Yeah, shoot them or something. No, there's 2 of them. So these are 2 millimeter apart from edge to edge. And if I measure the hole, it's 2 millimeters. 4 millimeter between hole. Sorry. Yeah, 2, 3, 4. Yep. So if I take the very outer hole and I go to the very outer hole, I get, come on, man. 102.0E. What the hell? Looks like the outer edge of the LCD isn't. Yeah, it might be about time to get some new calipers around here, huh? Yeah, calipers are starting to show their age a little bit. I'm getting the letter E. 178.04 or 100 and E. 78.04. Okay. So 78 millimeters. 78. Well, we add 2 to that. That ain't right. Wait, 80 millimeters is what we read from inside to inside. Now we're doing outside to outside and we're getting the same number? Hold on a fucking sec. Are all of my measuring devices dying on me? That could very be the case. That may very well be the case. 91. That makes more sense. Jeez. So 92. So 94. No, that's that same freaking measurement. That's that same measurement. So I guess we could use these centers. I mean, that's what we determined too, was that those centers were the right location. Cool. Okay. So that is going to be, and for my purposes, I'm making them 2.2. I'm going to make them 2.2, but rest assured they're actually 2.2. And then we go in from there. Why is that highlighted like that? Why is that blue? That should not be blue. Oh, Jesus Christ. I hate it when it does this. Oh, all the rules that have dictated where this thing is supposed to be have blown up. Did I not just click to put a circle there? Okay. 94. There's a separate 94. I don't know what the separate 94 is doing. Oh boy. What did that break? Yeah, there's I don't know, there's conflicting measurements here. We can still rescue this. My screen went black. Almost had to restart my computer. Time to rethink this. Oh no, man. Sorry to hear. I don't know why there's two 94s dimensions on this. This is there's one is for like the solid outer thing, and the other one's for the construction lines, I guess. Oh boy. Anyway, we can recover from this. This is fine. Everything's fine. We just need to make sure that this locates itself on the right thing. And I make that 2.2. See, now it's a locked dimension. God. Okay, so we're coming in here with the construction line, and we're going 4 from that. And then we're coming in with a non-construction. We're making that a 2.2. Then I'm coming in with a third line, believe it or not. I'm going to make that 4. I'm going to make this a 2.2. All these errors originally started from not being able to assume that the holes were symmetrical because something went wrong with whoever was drilling out the carbon fiber. So whoever made the carbon fiber part did something wrong, and that cascaded the error all the way through basically my entire model. So mirror those there. Oops, no. Mirror you here. Ta-da. Okay, that, and then mirror 1, 2, 3, 4, 5, 6. And mirror those on the assumed center, which is this little line right here. I need to select it. There. Look okay. And now those radii look totally sensible. God. Why does everybody want my CV? Jesus Christ. My major, I studied electrical engineering, controls and motors. The reason that I'm doing computer modeling, well, because I want to build a little RC car. But my career into being a maker has taken me on a totally different path. You know, I'm not a spreadsheet jockey engineer in a cubicle. I like doing this, where we get a little bit of every discipline under our belts. All right, there. All that's fixed. I think we finally fixed this thing. And what we did before was accursed and destined to fail. Let's check it against the rest of the RC car. And then everything's wrong, and I cry. I cry. Yes. Yes. Fuck! Why is that wrong? That should not be wrong. That should be correct. Wait, unless we didn't move it? Because that gap is still wrong? Well, that one's correct. What happened to... Ah, fuck. How'd you survive engineering? I mean, a little bit of the perseverance that you're seeing right now kind of carried me through. I think maybe that moves in. Yeah, wait a minute. These holes are in the wrong place now. That's correct. Okay, so yeah. I'm gonna dirty up the timeline with more movements. Oh god, the timeline on this project sucks. I might have to like save all for revision. All right, move component. Move zig. You have no chance to survive. Make your time. No, you're not moving. The rest of you are coming with me. You and you. I mean, the other answer for how did you survive engineering curriculum is that I'm smart. That's the only thing I could say. So what do you? I don't know. But I had to relearn a lot of how to do math. That was a big component of it. How does I math? So I had to do a lot of tutoring for linear algebra and stuff like that. Once it clicks, though, it clicks pretty hard. It's still off. It's still off. It's still off. Okay, so this whole odyssey of correction that we've been going down started off as trying to investigate why this gear was up against this face right here. My anger is palpable at this point. Those holes are gonna move back, I guess. This whole investigation was based on that. We corrected like a shitload of stuff too. But for some reason, and I can't put my foot on it, why is that off by so much? Oh man, this is really pissing me off. You guys can see about the cascade of numbers. We've got measurements that are based on 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 measurements. And I've been going through and selectively correcting all of those measurements upon measurements that are wrong. Wait a minute. Okay, this might be it. Distance from here to here has changed. It should be like 4, right? From here to here. Yeah, 3.75. Okay, that's wrong. Good. That's good that it's wrong. 3.75, whereas I get 4. So we need to move this forward 0.25. Okay, it's starting to come together. It's starting to make a little bit of sense. Move copy. Components. U. Cardinal direction. 0.25. It's still not there. It's still not there. There to there. Why are you not giving me a number? Oh, there it is. 4. Yeah, if there was ever a time for Swedish curse words, it is now. I mean, max I could give it is 4.12. How's engineering in the corporate world? I don't know, man. I did government stuff. I was a contractor. How is this so wrong? How is this so wrong? Everything else is right. Ish. I measured this one several times. Six. Really? Six? Six seems like a bit much. Yeah, 5.79. That would move this. That would move it the opposite direction. Man, listen, man. I'm not doing a job interview with you right now. Sorry. Yeah, because I observed it. All the measurements are wrong. That's how it feels right now. That's what it feels like it's doing with me. I mean, you know, like I designed the part to have that space there, and I measured everything. Everything seems to be the right dimension. Everything seems to be, you know, sitting in the right spot. But I don't know. So what my huge frustration is right now is that with everything correctly located, the part that I printed should have a gap there, and it just does not. And that doesn't make any sense to me. It even looks like it's being pushed back a little bit by the gear. And if that doesn't make sense, well, then what else doesn't make sense in this model? This is amazingly frustrating. This is incredible. Everything else I've done seems to be, you know, like, look, that little corridor right there between the battery mount and the part that I printed, that's on the model. That's right damn here. Little corridor right there. Oh my God. I do not know what the deal is with this. Last ditch measurement. We'll go from here, go from this face out to the end here. We get 24.5. It's very hard to see those numbers. I measure it over here. Wish I could offer helpful solutions, but I feel your pain. Ah, it's okay, Groove. I know. It's all good. It's all good. 24.5. I'm getting it almost exactly on the calipers. 24.5. Oh, man. Chat, I am frustrated. I don't know what the fuck is going on with this thing. How's that looking? It's fine. That looks fine. There's a chance that maybe, you know, some of these holes need to move around a little bit. Probably not much. Those line up. Those we made line up. These probably, there's just like a number on them that I need to change in order to get that to line up properly. The measurement from the edge to this face is fine. The measurement from the edge to this hole right here is fine. That lines up with this one up here, which works. This hole indexing to the edge, I've done before, it's fine. All these parts line up, all these squares make a circle. All of this stuff lines up. Why then is there a gap from here to the gear? That shouldn't be. All right, I have, maybe my printer sucks. I don't think that's the case though, but I'm gonna have to call it quits here. We're like almost a half hour over. I want to thank you guys for coming on this little CAD journey with me. We're gonna take a look at I mean, there will be other CAD stuff that we need to do on Thursday. We're gonna take a look at the streaming computer case. So we'll start figuring that one out. I got most of the idea of what I'm gonna do. I'm basically gonna follow lessons from the completed server reskin project, where I put basically hexagonal mesh and orange 3D prints up in front of that thing, which will look really cool because there will also be a flat reservoir out in the front of the computer. So that's going to look really cool. We got most of the information that I need on that project. So it's going to really kind of be like laying things out, figuring out where tubes and stuff are going to go, and then we can do partial assembly, and then I can figure out what I need to 3D print, and all that stuff will transfer all the parts in the current streaming computer into the rack case, and then the rack case goes in the rack, and then I've got a bunch more desk space. Space for my desks. My deck. No, not deck. I'm not sending anybody deck pics. For my desk space. I sent you desk pics. Please reply. I can't even talk straight. This has been a very fiddly process to try to get this stuff right, and I'm still struggling with it. Yeah, hit the deck. Best protect your deck. Wait, did somebody do that? Did somebody do the Wu-Tang best protect your neck, but for like protecting a deck and selling like sealant? 12.275. 12.275. I get the calipers, turn them on, and I measure, and I get a number. And the number that I get is 12.4. Which 275 and 0.4, I know they're off, but the pieces kind of wobble around a little bit. There's just a little bit of wiggle room in there. 11.7 on one surface, on the other I get 12.15, 12.25, 12.275, 12.15. Good stream. I learned some things, though I don't use Fusion 360. Yeah, man, you learned how much of a pain in the ass it is to reverse engineer mechanical things, which is what I'm learning too. I'm learning this stuff with you guys. All right, I don't know what the hell is wrong with my model. I don't. Maybe I changed the dimensions of this thing at some point. I don't know. It just seems so weird that everything would kind of shift like that. I still have a bunch of revisions to do on this solid. I just really wanted to make sure that my distances were correct, and so this distance here wasn't adding up from here to the gear. I wanted to make sure that that gear is in the right spot. According to what I'm measuring, it is, but something else isn't lining up, and so that fills me with a feeling of dread that something else is horribly wrong. Like, we were able to get down to the fact that this piece right here was misshapen from whoever produced it. So I need to stretch some of the holes up here in order to make them fit on the physical piece. Or I could 3D print another one, but I don't want to do that. I'd rather have the carbon fiber part. Of course, if I have the carbon fiber part and I stretch the holes, does that mean that the model can then flex like that? I guess the screws will hold it down, but then I am relying on friction in order to keep it in place and not have the pan of the car flex. Yeah, that's an interesting one. All right, anyway, I'm going to leave you guys to your own. You guys figure out what you want to do with your lives. Back on Thursday, we might end up in Fusion 360. Probably are. We're going to do computer layout stuff. I will see you then. Yeah, fill the holes with epoxy, and when you put the screws in. No, I don't want to epoxy it down. What I could do is take carbon fiber dust and mix it with epoxy, and then put it in those holes. But I'd have to talk to Flatulent going out about how to do that. I'm not too confident. I could load it up in a syringe and do the little frosting thing. All right. Yeah, I'll see you guys. Let's go to the face cam. Let's go over to here. Check out what's going on. I may just end. Ba-ba-da-ba-ba-ba-ba. Borb is doing a painting. Adam is editing. Banners of Ruin. I don't even know what that is. Yeah, I'm just gonna stop the stream. I'm just gonna end it. Just end the stream. It's, I'm gonna keep working with this stuff, and we'll figure out where we get from here. So I will see you guys later. Have a good one, and I will see you. Oh, Dexpo. Yeah, Dexpo streams a lot. I've only just recently started following her channel. Check that out a little bit more. But yeah, you guys check out Dex Bonus because she raided the other day, and it was like a big fat 700-person raid. BMO's streaming too. Is that the voice actor for BMO? Is that what that is? Because that's cool. Wait, is Ghost Freak is on too? Oh, he's doing a different game, so nobody's watching. Oh yeah, BMO, Better Monster. Oh, Jesus Christ. It's a friend of mine from college. Better Monster. She does crochet and stuff like that. She has a lot of really cool little makers things. But yeah, anyway, there's everybody is on a Tuesday afternoon, so I will see you guys around Twitch. or on Discord. And I will be back on Thursday. Goodbye.